Hi, and welcome to the fourth edition of the Virtual Azure Community Day. I'm Alexia from Microsoft, and I have the pleasure to be your host today for the next 4 and something hours. I also be pleased to welcome and to be joined by Maud Levi at the end of this track. If you have any questions or remarks in the line with the code of conduct, of course, you'll be well received by our team on YouTube. So shout out to all the team behind these events. So today we're going to talk about DevOps, about GitHub, security on Azure, machine learning, and many other subjects that matters to you. So please turn off your notification, your phone, or any distractions because you're about to enter the Azure world for one afternoon, and you're just about to go in an event that was concocted with love by our dev communities in France. So let's start with a warm welcome for Barbara Forbes today. Hi, Barbara.
How are you?
Fine, you?
I am good.
What time is it for you?
I'm in the Netherlands, so it's the same time as in.
Oh,
France.
nice. So you didn't have to get up early.
No, I'm happy not to.
So, Barbara, someone told me that you're a GitHub star. So, for a newbie like me, can you tell me, like in one sentence, what is GitHub, and how you're going to prove that this is the best way to use your tools?
GitHub is a platform that you can use to store your code, which you use in a Git context. And GitHub Star is the program that GitHub has started. It's sort of like the MVP program that Microsoft has. So it encourages people who are active in the community. You get sort of an award, to say it like that. So appreciation for the contributions to the community. And it's been a lot of fun. I've been a star since February this year, so relatively new. But I've had some amazing experiences with GitHub, working especially with infrastructure as code and PowerShell, that kind of tools.
Well, congrats, because you have the two recognition. Congrats, and I'm going to let you go with your talk. Thank you so much for being with us today, and see you in some minutes.
All right, I think we're a bit early though, but I guess I can get started. Let me just set my timer real quickly because I forgot. All right, and let's go then. We're going to talk about how you can deploy to Azure and the comparison between Azure DevOps pipelines and GitHub Actions. What I'm going to try to do here is give an objective overview, which is pretty hard to keep objective when you're comparing two different tools. But I want to show you how these different tools compare with each other and the differences and the things where they are the same. About me, my name is Barbara Forbes. I am an Azure MVP and a GitHub star, like we just discussed. And in my daily job, I am the Azure technical lead at OGD in the Netherlands. I write a blog about Azure and automation and a lot about Azure DevOps and GitHub as well. And you can find it at forbes.nl. And if you want to follow me on Twitter, you can find me at BA4BES, and that is also my GitHub handle. So let's dive right into this. Yeah, there we go. So let's consider a little bit on what we're going to do, what we're going to talk about, because we're going to talk about deploying to Azure. And we're not going to use the portal for that. We're going to use infrastructure as code. And what you usually have is you have your infrastructure as code. This can be ARM templates, this can be Bicep, this can be Terraform, this can be any other language that fits what you're thinking of. And what you can do is have them on your local computer and deploy to the Azure environment. locally. So you connect to Azure and do it like that. But that can give you an inconsistent experience. So what you want to do is have it stored on a platform. So in this example, Azure DevOps or GitHub. And from there, you want an automated process that when something changes in your code, it's automatically changed in Azure. We call that a CI/CD pipeline, and I have to be honest, that's in this case we're just going to create a CD pipeline because we're not going to do any testing for the sake of time. But what you run that on is an agent where you run a pipeline. So the different two pipelines we're talking about is Azure DevOps pipelines on the Azure DevOps side and GitHub Actions on the GitHub side. And what these pipelines basically do, if you scale it down a lot, they do a bunch of tasks. So you get an agent available, which is an OS, just like your local machine, and a bunch of tasks are run automatically. So it's something that you might even be able to do in your local machine, but then it's all in the cloud and automatically. So these tasks are some examples I've written down that you can think of, which are available as default tasks, so you don't need to configure them yourself, are a Terraform init, Terraform deploy, PowerShell tasks, do anything with PowerShell, ARM template tasks are available. Azure CLI is also available, but there are also specific tasks if you want to push your code to Azure resources like Azure Functions, web services, or a Kubernetes cluster. So these are available on both these pipelines, and now we're going to compare them a little bit. And to do that, I'm not going to talk about it too much. We're going to do a quick demo where I'm going to show how you can create your own pipeline, because can just do it within this talk. And after that, we will walk in through some of the differences and the different elements that go along with these pipelines. So I'll switch my screen real quickly to this one. And this one as well. Yeah. There we go. So for this example, we're going to work with one of my favorite resources to deploy when you do an example, which is a storage account. Why? Because it's relatively small in code and it's very fast to deploy, especially compared to others. So in both cases, we're going to be using this GitHub repository that I have available. And this has the code for one storage account. So we have the folder storage account. And in here is an Azure deploy.json. This is an ARM template for this example. And this is a basic ARM template. And there's only one parameter, and that's the storage account prefix, which is used to determine the name of the storage account. The rest of the storage account name is a unique string that is collected from the deployment. Because each storage account name needs to be globally unique. So otherwise it would fail if that is a static value and I deploy it more than once. So this has one parameter, and then we have a parameter file here, the Azure deploy.parameters.json, and here it says that storage account prefix. So that is the code we're working with. And let's first check out how we can do this in Azure DevOps. One thing that I've already set up is the connection to Azure. In Azure DevOps, you can do this with a wizard, which is basically a next finish, which can be a pretty easy process, but it does mean that your Azure DevOps needs to be in the same Azure tenant as your Azure environment. And it can be worth it to create it yourself because this gives it a lot of permissions. But for now, this works. And so we already have a connection to Azure set up. And here I can find pipelines in the left. So I'm going to click that. And I already have a pipeline here. That's the backup pipeline. In case this demo goes horribly wrong, then I have a pipeline ready to show you. For now, we're going to create a new pipeline. And first thing I can select is where my code is stored. So I don't have to use a Git repository within this Azure DevOps tenant. I can use one from pretty much anywhere. So that's already a pretty nice feature. I have it stored in GitHub, as you just saw, so I'm going to connect this to GitHub. And it's going to show all the repositories. There's a connection made here as well. I did that beforehand. And we're going to use the top one because that's the one I just shown you. I can configure a pipeline now. I'm going to take a starter pipeline. If you feel in any way, by the way, like this is going a bit fast, I do need to go a bit fast because of the time, but I do have blog posts on all the processes that I'm describing now. So here we have a starter pipeline, which is basically an empty pipeline. It has some stuff that we can use. First, it has a trigger, and by default, it's set to trigger to main. This means that the pipeline will run anytime something is added to the main branch of the repository. So if you're working in a developer branch, it's not going to deploy anything, but if you are working in the main branch, it's going to deploy, which is good. We want that, so we'll keep that. After that, here we have a pool. And the pool is the agent where your code will run. By default, it's on Ubuntu. You can also use Mac OS or Windows. And there are different versions available for that. You can also use your own agents. In this case, we're going to use Ubuntu because often Ubuntu is one of the quicker ways, and it's already set up. And after that, it defines some steps. And it has some hello world scripts that we're not going to use for this one, so we'll delete those. This is a YAML file, which you see here. And if you are from a Windows background, YAML will have one thing that takes some getting used to, and that's indentation. Indentation matters. So the amount of spaces here, the fact that there are 2 spaces here, matters for the code. And that can be a bit frustrating if you're just getting into it, but you do get used to it. So we're going to create a step here, and normally maybe you would do some testing beforehand, but as this is just an example, we're just going to straight up deploy. It's not that difficult of a resource anyway, should be fine. So to do that, I could write out the complete YAML, but I'm going to make my life a little bit easier when you're first developing a pipeline, and I'm going to use the assistant you see over here. So I'll click show the assistants, and I get a bunch of tasks available. And I'll scroll down a bit. As you see, there are quite a lot of tasks that are available by default. You can even add more tasks to this. So there's even more options than that. But the task that we need is already here. We're just going to search for it by pressing ARM. And it shows ARM template deployment. Sounds good to me. So we'll click that. And I can set a scope here, which will be the resource group. And as you see, I get these drop-down menus. And as I already have an Azure connection, I click it here and it will use that connection to get the right resources in Azure. So this has permission to 1 subscription, so I'll use that subscription. I want to create or update a resource group, that's correct. And I can select a resource group here. And this is the one I'm using for this demo, but it got all those resource groups from my Azure tenant. So that really helps. I can set the location here as well. And as I am in the Netherlands, I'm going to use West Europe. And now here I can actually set the settings on my code side. So here I can add the path to my template. And I'm not going to bother with writing that down because that's bound to fill. We're gonna copy and paste this real quickly. So my file was in storage account, the folder, and it's called Azure deploy.json. And after that, it wants the template parameter file, which was over here. So I can use that as well. And then this is a nice little feature. If you want some more flexibility, you can override parameters from that parameter file. So in this case, we can set that storage account prefix because that's the only parameter available. And I'll take it like this. And I will override it to say as though, so that I know the storage accounts, because there are a lot of storage accounts in that file, they are from Azure DevOps. And actually, I'm going to add 1A, because like I said, I've done this demo a few times to practice and to test, so there are a bunch of storage accounts already in there. So now it starts with AA, it should be somewhere at the top. And for deployment mode, I can click incremental or complete or validation only, which is really nice for testing. And I'll leave it to incremental. And now what I can do, I do have to make sure one thing, that my cursor here is in the right place, which is from steps and then 2 spaces, because indentation mattered. And if I click add, it will generate all that YAML for me. So that saves me a lot of time on looking at the syntax. And I'm not saying you have to do this like this every time, because this is code and you have to make use of it. You have to reuse it. So don't have that assistant out there all the time, but use it to set up the base for each steps. But for the basics, it's very handy, in my opinion. And we're going to click save and run. And once again, and it's going to commit this file to the repository, and it's going to be available there. And this might take a second for that pipeline to start. And there we go. The pipeline is now part of the code, part of the rest of the repository, and it's now being queued, and it will start running in a second. Now, we're not going to wait for that, because that would be a boring demo. We'll check back later to see if it's done. While we'll wait, let's move on to GitHub. So here I have the GitHub repository, and I've opened it up on the same screen where you can find the connection to Azure. This is a little bit less integrated than in Azure DevOps, as in that I make use of secrets. What I did, I created a service principal on my Azure tenant, and I got the information I needed from that in a JSON file. So the secret and the application ID and stuff like that. And I have added this to the secrets within this repository. Now, this is pretty secure because I can double click. I can't do anything with it. I can't view the secrets. I can update them, make them a different value. I can remove them, but I cannot see those secrets. I can use them in my action though. So we're going to move on. In the menu here, you see actions. And over here as well, I already have a workflow in case everything goes wrong. But let's create a new one right over here. And you get a template as well that you can use. And they have some different templates available, but there's none for infrastructure as code at this point. So we're just going to use simple workflow, which is a very basic Hello World workflow. So first thing I'll do is I'll change the name. The name by default of this file is blank.yaml. And I'll make that a little bit more descriptive and call it Azure deploy.yaml. Could also deploy storage account.yaml. The sky's the limit. And as you see, we have YAML here as well, but of course, everything is just a little bit different. So let's just walk through that. The good thing about the pipelines in JSON is that they have a lot of comments to show you what all the stuff is actually doing. This is very handy. So we have the basic workflow. The first thing we have to do is give it a name. And this name will be how it is displayed on that action page. So it is nice to have a descriptive name. So let's say Azure Community Day. And then we can control when the workflow will run, like we had before with what triggers the pipeline. Now we can also control what triggers the pipeline to start running. And in this case, it says basically the same as the Azure DevOps pipeline. It will run when a push or pull request is done to the main branch. Next to that, you also have workflow dispatch. And I don't think this is the most intuitive as a name, but a good thing there's a comment on top of it that says allows you to run this workflow manually. You are not able to do that by default. So this is always good to leave this in there. So you'll be able to click on it, which is always nice. And then we have the jobs here, which we can run. And the first job here is called build. And that's not a good name because we're not going to build anything. We're going to deploy something. So I'll change this to deploy, which is a better name. And here we see again runs on. So we can tell on what agent this job will run. By default, this uses Ubuntu, and we're going to stick to Ubuntu. There's one extra thing in the steps here, and that's a checkout action. And this makes your code available to the agent. So you need this in here. So always leave this one in your folder. And then again, here we have some hello world functions, which are nice, but we don't need them. So we'll delete them here. Oh, forgot one. There we go. And here on the right, we see something kind of similar with that assistant. We see the marketplace, and there are a lot of options in the marketplace. The marketplace is created by created by the community, so it's open source. All these things you see over here, all those different actions, are created by the community, and there are a lot of them. And we will see some options that are available in that marketplace. Talk about it a little bit later. But first, we need to log in to Azure before we can do anything with Azure. So to do that, we will search for Azure login. And this is the action that we need. Now, there is something handy here, is that you can see that this is created by Azure and verified by GitHub, that Azure is the Azure that you would expect. So this is not community-based, this is created by Azure, which means, yeah, this should be the right one. So we'll click this one. And what you get is a short description, and then the option to view the full marketplace listing. And over here, you can say copied. And you can copy the page over there. And the full marketplace listing is where you can get all the information, all the documentation. Basically, that brings you to the repository where all the code is, because everything is open source and visible. So we'll copy and paste it here. And now we have a bit of an issue because that indentation is wrong. It's not at the right place. So what we'll do, there's a nice little trick here to put it at the right place. If you press your mouse and then, no, other way around. If you press Alt on your keyboard and then your mouse, you can drag it along and you can put spaces in there for all the lines at the same time. So you don't have to do it, all of them, manually. And then my little trick to get the indentation right, you see that it's wrong by the red little squiggle. I'm not going to bother checking what the indentation should be. I'm just going to press space until the red squiggle is gone. Oh, there we go. That's the right place. It's a bit lazy, but yeah, it works. So it uses the action Azure login, and little tip, this is the name of the account and the repository that this action is in. So if you add this to the URL github.com, it will bring you to that repository. And the first thing we can add is the credentials. And what we do is reference to the secrets like we did before. So here I have the value that you can use for that. So this is the syntax to reference something. And in this case, we're going to reference, get away with pop-ups, secrets, and then that Azure creds, because that is the secret I just created. And if you look at all the options, all the other options, they are all optional. So I'm going to delete them all because this is all that we need. Leave it like that. And now we're actually going to deploy our template to Azure. So I'm going to search again. And here you're going to see what is one of the tricky things with a big marketplace with a lot of options. If I look for ARM over here, I get a lot of different options that are not what I'm looking for. They are very useful though, but they're not what I'm looking for. And there's actually something interesting. If you look for ARM, I already see over here 2 different versions of the ARM TTK. And I think if nothing changed, there's actually a 3rd one here. These are all made by someone in the community. So this means in your case, if you need an ARM TTK, action, that you would need to check all of them to see which one fits your needs the best. So which one is the most right for what you need. So it does require a bit more research, but it gives a lot of flexibility. Now, if we scroll down a little bit, here we have deploy Azure Resource Manager template by Azure. So we know that's the right one. So let's click on that again, and we can copy and paste the code and put it over here. And this is a bit longer, but we can do the same trick of pressing Alt, going all the way up, and keep clicking space until the squiggly line is gone. Did I go one too far? Oh, I think I went one too far. Yeah. See if we can get them back. That's always a bit more difficult. There we go. And oh, it didn't pick up this one. Okay, it's not completely foolproof, but we'll make it work because this one needs to be one further. There we go. No reason to panic. So here it says again in the comments here what we need to provide. So here they say you want the scope of the deployment, which will be resource group. And here it says override subscription ID by the Azure login. No, don't find that necessary. I know the subscription ID is already fine. And here it says only required for management group deployments, and here only required for management group or subscription deployments. We're not doing any of those, so I'm going to remove those as well. And for a resource group deployment, I need to add that resource group name. So I do need to do it manually. There's no drop down here, but yeah, that's not that big of an issue. Often you have some kind of automation in here as it is. And then here we can verify the template. So put the path to the template there. And I'll use Azure deploy.json again. For the deployment mode, we'll use incremental again. And now there's one thing here, the deployment name. So every deployment job in Azure gets a name. And usually, I'm honest, I don't really bother with setting that name because it's not that interesting to me. But the thing is with the GitHub actions is by default, they all have the same name for the deployment, something like Azure Deploy, I think. And that means that if you deploy a lot of them, if you deploy this pipeline more than once in a very short time, it will just think that it has already done that deployment because the name is not different. So it is good to make sure that every name for the deployment is different with GitHub Actions. And what you can do for that is use this code. So what this does, it uses GH as the first two letters, which is for GitHub. And then it uses that same formatting we had when we set up the Azure credentials, but now it refers to GitHub and then the run ID. So it will add the ID of this run to the name of the deployment so that it will have a different deployment name for every time the pipeline runs. And now, last but not least, we set up the parameters. And you do that basically the same. So storage account / Azure deploy .parameters.json. But now if you want to overwrite some parameters like we wanted to do because we want to change the name of the storage account, then you can do it like this. So you just put a space after the parameter file and then add the specific parameter you want to change and what value it should be. Last one is optional as well, so I'm going to delete that and we are done. I can start a commit a new file, and it will start running. This is, to me, still a bit counterintuitive. It will go to the folder where all your GitHub workflows are stored. So this is the file it has created. It shows that. But if I move to actions over here, you see it has started. So the action is now running, and we can see that it's doing its job, starting an Azure login. While this is starting, going pretty fast today, so that's good. You can see this one has finished already. And let's look at Azure real quickly. This is the resource group that we were deploying to. And let's refresh. And there is one added. Yeah, there we go. AAZDO is now added to it as well. So that was the storage account we just created. And if we go to deployment, we see the GitHub one is deploying one now. And actually, I changed something in the repository so that one in Azure DevOps also started a new run of the pipeline. And this explains a little bit why I have so many storage accounts there. I did already remove a lot. I had like 50 and I removed them and now I have 27. But yeah, you get you get the point. If you have more than one pipeline, it can get crazy pretty quickly. So anyway, that's how you can set it up. That's a really quick overview. Of course, there are a lot of more options available, but yeah, this is the basics of that pipeline. And now let's look at a comparison between for some different options between these pipelines. The first thing I was interested in was speed. Is one of the pipelines quicker than the other one? And the results were actually, well, I thought this was interesting. If you look at the results here, I started 5 pipelines for both Azure DevOps and GitHub Actions right after each other. And what you see here is that the Azure DevOps ones are a bit faster. They are like 44. The slowest is 51 seconds. So pretty impressive, I must say. But they are pretty consistent and they are a bit faster because if we look at the GitHub Actions, we see 1 minute 50 even as the largest one, which is almost twice the time, and 1 minute 25 for the shortest one. So it seems there that Azure DevOps is a bit faster. But then I looked halfway through these deployments, I looked at my Azure portal at the resource group, and I saw this. I had 5 GitHub repositories and only 2 Azure DevOps storage accounts. So only 2 came from Azure DevOps, while GitHub had already pushed 5s. And the reason for that is that in GitHub, by default, you can run these actions in parallel. So if I trigger 5 of them, it will run all 5 of them. And Azure DevOps by default only has 1 parallel job. And you can add on to that if you buy licenses, but the free version has 1 by default. So what I found is that the timer for these pipelines only start at the point that the pipeline actually starts. So if in Azure DevOps a pipeline is queued a lot longer, then the statistics can make it seem it run faster. But maybe it didn't. Maybe in the end result, I think they are pretty similar. Now, these are very fast pipelines. So it might be a bit different if you have pipelines that by default run for like an hour. Which is, by the way, a very slow pipeline. So maybe you should look at what kind of code you're using. But anyways, a 10-minute or 50-minute isn't really out of the ordinary. Could happen, and then maybe there's a bigger difference. But with this information, I would think the speed is pretty much the same. Then the agents that we already saw. Next to the agents that you have available for both Azure DevOps and GitHub pipelines, which are Mac, Linux, and Windows agents, you can add your own agent. This means you make your own virtual machine or container and you install the agent on there, and then that machine will be used to run all these tasks. This can be very useful, for example, in an enterprise environment where you don't want that external connection from Azure DevOps or GitHub, but you want the code to be running from the inside. So if you have a closed-off network, that might be very handy. It also means if you're deploying to Azure, you can make use of the managed identity of the agent, which is a pretty secure solution. Another use case can be if you have a lot of software that you need to run for your agents, or if you need very extensive PowerShell modules. They can take a lot of time, so maybe then it's better to have an agent with all that software or all those modules already installed. Can be a bit quicker. In both of the platforms, you can add an agent. They, of course, have a slightly different name. In Azure DevOps, it's an agent pool, and in GitHub Actions, it's a runner. And the fun thing is I did create both of them, and I'm pretty sure they have the same installation program. in the backside, because it's very similar process to connect them to each other. They both work very well and pretty much the same after they have been installed. Now the tasks or the steps or the actions, that is a big difference though. What is available? On the left, we have the Azure DevOps Marketplace, and you see there are almost 1,300 tasks available that you can use. You can see some third-party here tasks that are very popular here, the Sonar Cloud or the AWS Toolkit, stuff like that. And you can use those in your pipeline. You can install them into your organization, but this is not that open. You are able to create your own tasks and you can make them available to specific organizations. That is possible, organizations that your account is part of. So you can make them available for your own needs. But if you want your tasks to be available in the marketplace, then you need to apply to that. So you need to prove that you're going to maintain the code. So they have some quality checks to see what is in there, which is nice because it means that everything that in there is overall good quality, but it can be a bit higher threshold to start developing for it yourself. Then on the GitHub side, we have the GitHub Marketplace, which is as open as it can be, more or less. You can probably get removed, but anyone can put something in the marketplace. And that means that although the Actions Marketplace is relatively new, I think they have just topped 10,000 actions in there. There are a lot of actions available. Which means you can make use of a lot of stuff that other people have already done for you. So really the open source concept, and that can be really great. It also means that you do need to check in on, like you just saw before, we have 3 tasks with the same name, the same goal, or more or less the same name, the same goal. So you need to do a little bit more research on which one you're gonna use. But if you do that research, make good use of those check marks that you see here. So the check marks that say which says this is a trusted company. Make use of that. Make use of the amount of stars that an app has received. Then you can make very flexible pipelines. This also means you can very low threshold add your own tasks to the pipeline, to the marketplace. You are even able to just create an action, and you don't have to put it in the marketplace to use it in your pipeline. So you can just refer to the GitHub repository where it is, and then you can use it. Only thing you need to do is make that repository public. It doesn't work in a private repository, but you don't have to add it to the marketplace. But you are welcome to if you want to share it with the community. So that's a big difference. In my opinion, there is no right or wrong in this. It's just a different way to work. Now, to connect to Azure, we saw it already a little bit. On the left side in Azure DevOps, you can make use of a service connection, and in GitHub, you can make use of a secret. Service connection is a little bit easier to set up because you get some wizards up there, and it is by default, of course, already connected to Azure if you use Azure AD. So it's a little bit more low threshold, but the Azure Secrets one works fine as well. And for both of these, you pretty much only have to set them up once for your repository. And that actually brings up an interesting difference between the two pipelines. In Azure DevOps, if you set up that service connection, you can use it for any pipeline within the project. And your project can contain multiple repositories. But in GitHub Actions, your pipeline is always connected to your one repository. So the scope is different. So if you have another repository where you want to deploy stuff to Azure, you will need to add a secret there as well and have the pipeline separated. So that's a different way of structuring your information. Now, the variables, as everything, you can work with them, you should work with them, works very well. And as always, they are the same, but have a different name. So in Azure DevOps, they are just variables, and in GitHub Actions, they're called env for environment variables. they are both the same thing, environment and variables. To work with secrets, well, we saw it in GitHub Actions already. You use secrets for your Azure credentials. You can use them for other stuff as well. And in Azure DevOps, you can use a variable within the pipeline. You can set it up there and have a little check mark there that says, keep this value secret. It is possible to collect it if you use the right amount of scripting. So it is good to be careful with that. The best thing to do in both cases is to make use of Azure Key Vault. You do need to use those Azure credentials to connect to Azure, but store all your secrets in Key Vault and then collect them from the pipeline. There are default tasks available for both pipelines. So that's always the way to go if you're working with secrets. This, however, is very handy if you're working with a test environment. And then enterprise integration. And I must say, with GitHub Actions, it feels almost like cheating a bit because I have used the free version and not the enterprise version. But especially working with Azure, it is something to consider that an Azure DevOps has a by default integration with Azure and with Azure Active Directory. So the users that you have in Azure are by default from your coming from your Azure environment. While in GitHub Enterprise, you do need to set it up. You can set it up. You can set up semi-authentication with an application registration, but it's something you need to set up yourself. I haven't had a lot of experience with that yet. I know it's possible. There might be some issues there, but that's something to keep track of, that it might be a bit different if you're using this for the enterprise. And then the costs, which is always interesting. On the Azure DevOps side, you are focused on, you have the licenses for users, but you can pay for using those agents and for using those pipelines. You can pay to have them run in parallel, and you can pay to have extra available or extra minutes. While in GitHub, everything is based on what kind of user account you have. In both cases, the good news is that you get a lot of free minutes. So in Azure DevOps, you get 1,800 minutes. In GitHub, you get 2,000 minutes by default, and that's a lot of minutes. You can play around with it without any issue. So there's a lot of options there. You do need to check on the Azure DevOps side that sometimes they disable it, but you can just ask if they can enable it, because there was a lot of malusage on the internet, because that's why we can't have nice things. But for testing environment especially, you can play around a lot. 1,800 minutes is a lot of them. So to conclude, they're the same but a bit different. And I think there's a lot to be said for your own preferences. Like I said, I try to keep it objective here. One thing that I really believe, though, is that if you are already familiar with one of these, or if you're learning about one of these, it's worth it to learn about the other one, because they are so similar that, for example, if you're already familiar with Azure DevOps pipelines, put like 2-3 hours into GitHub Actions and you feel like you already understand, because the process is very similar. It's just those small changes, the fact that things have different name, and this can really help you with broadening your information and your knowledge. So if you are familiar with one of them, or if you're learning one of them, take that little bit of extra time to learn about the other one. And that was all the information I have. If you want to have a step-by-step guide on what I have just talked about, you can find my blog, forbes.nl. You might have to search a little bit for GitHub Actions or Azure DevOps, but I have some step-by-step guides on deploying ARM templates and testing them and stuff like that. If you, I think we have some Q&A now, but if you have any questions later, you can always hit me up on Twitter. And thank you, everyone, for listening.
Thank you to you, Barbara. That was really nice. And I have some questions from the people just looking at your show right now. The first one will be like regarding the different approach with tasks that you spoke about. There are numbers and the quality check that differs a lot. In which case do you think you'll choose one over the other regarding the other as the main system for the whole company?
So you mean in like as for GitHub, where you have like the ARM TTK we saw, and we have three of them, and which one should you use, right?
Yeah.
Yeah, what you can do, like I said, you need to read through the information. Most of these have pretty much good documentation, and all of them are open source, so you can just see the code that was used to write them. Another thing I would look for is how many contributors have there been, how often has there been contributions, is it maintained, does it have stars already, and most specific, does it fit specifically what you need. If it doesn't fit it specifically, maybe one of the other tasks does. So the first time you're going to use it, you do need to do a little bit of research.
Okay. Well, that's always a good advice, I think,
Yeah.
to do a little bit of research. The next one might be a tricky question because I think that you said that you don't have any preferences, but do you have in your hearts one preferences between GitHub Actions and Azure DevOps Pipeline?
Well, I like them both. Otherwise, I wouldn't be doing this talk. One thing that I like to work with, though, is that I like to have everything in one place. So if I have a GitHub repository with something for the public, for example, I like to use GitHub Actions there as well to deploy it wherever it should be. And if I'm using an Azure DevOps environment, so I have a repository in Azure DevOps, I like to use Azure DevOps pipelines. So that's my personal preference. You can, of course, mix them up, but I do like it if I have something specific in GitHub that the actions are also there and the pipeline is there. So then I have a preference for GitHub Actions, and if the code is in Azure DevOps, I have the preference for Azure DevOps.
Okay, so it depends on the environment, right?
Yeah.
That's the whole key. Well, do you have some tips on testing infrastructure as a code in a pipeline?
Yeah, because what we did now is just look at the deployment.
Mm-hmm.
And one of the great things about this pipeline is that you can do some testing before maybe something you don't want in your production ends up in your production. So you can do some automated testing there. There are some options. As I showed briefly, you can have a validate step, which just checks if the context or the structure of the ARM template is correct.
Mm-hmm.
Another option you have is to use the what if module, which is now available in both PowerShell and Azure CLI. You can add what if to it. And what the command will do is show you what would be deployed if you run it without actually deploying it. And one of the great things it does, for example, it also shows if something would be deleted. So if you run in complete mode, you can say, okay, I want to run this in complete mode, but if something gets deleted, stop the pipeline. You can write some scripts surrounding that. So that can be very useful. And next to that, of course, the ARM TTK, which we saw in those tasks, which is a quality control on the ARM template as it will be put in Azure. So that's also very nice. And you can think of custom tester testing.
Okay. Well, those are really nice and
A
great
lot of
tips.
options.
Yeah, a lot of options and a lot of many possibilities. So do you have any recommendations? So you gave us like the tips to test the infrastructure, but do you have any recommendation when choosing the infrastructure as a code solution?
Yeah, there are some different opportunities there, and I used ARM templates here because they are the best known. If you connect to Azure, you can actually export them from Azure if you want. There are some other ones around. If you are using a multi-cloud platform, then Terraform might be more fitting for you. But one of the greatest new players that have come around is Bicep, which is sort of a layer around ARM templates, and it's a lot more flexible to write with, and it's really a very impressive language surrounding ARM templates, which is really, it is only for Azure.
Mhm.
So if this only if you only deploy to Azure and you have been working with ARM templates or something else, give Bicep a try because it's really a great language to add to your infrastructure as code.
Okay. Okay. Well, thanks a lot. I think the questions are done on my side, but maybe if you have like one thing you would like the audience to think about and to come to get from your talk, what is it?
Well, that everything I just showed you can really help you up your stage, and you can try everything for free. Like, yeah, you need to pay for your Azure. Well, Azure, you can get a free account as well, but it's temporary. But those pipelines, the code that you store, everything you can play around with for free and get familiar with it and see if it's something for you. So I really recommend get into it. Just try it.
Put your hands on it.
Yeah.
Well, thanks a lot, Barbara, for being here with us today. Thanks
Thank you.
for opening the show. You're the
Yes.
first one, and many to go after. But yeah, thank you a lot, and see you next time. I hope in the next VACD.
Yes. Thank you. Bye.
Getting started with Docker when using Azure is amazing because we have so many different ways to get you introduced to it and then grow you all the way up into something like Kubernetes. To get started, you can use Azure App Service, which is an amazingly easy service to stand up, and there you just point it at an image you want to run, we'll download the image for you and host it inside of App Service. Using App Service, you get to take advantage of all the cool features, for example, deployment slots, instant scaling it up and scaling it out, and you've been able to do that by just learning a little bit about Docker. If you wanted to spin up your own Docker cluster, you could do that yourself using all of our VMs, or you could use something like AKS. AKS is our Azure Kubernetes service that allows you to now have a fully orchestrated environment where you can run all the workloads with containers that you want to. So no matter if you're just dipping your toe in it and you want to start with App Service, you can. If you're ready to use things like Kubernetes, we're ready for that as well. So wherever you are on your container journey, we're here at Microsoft to help. AKS, or Azure Kubernetes Service, is our offering of Kubernetes in Azure. It's really cool because the control plane is completely isolated from you. We take care of it, we monitor it, and you don't even pay for it. All you worry about are the workloads that you want to run in your worker nodes, or what we call node pools. Inside of AKS, you can actually have Windows node pools right next to Linux node pools. So there's one Kubernetes cluster where you can run your Windows or Linux workloads side by side. One of the biggest pains of having a Kubernetes cluster is upgrading your nodes and upgrading your control plane. And in Azure, all you do is you go and select a dropdown of what new version you want, and we'll make sure that all your nodes and your control plane are completely updated to the proper version. We also have a really cool feature inside of AKS called dev spaces. You've all had that bug where you can only produce it in production, and you can't imagine how much it would cost to spin up an entire cluster to look just like production. But with dev spaces, we can actually spin off just the nodes that you need inside your production cluster, isolate it from production, yet give you that exact same experience. So you can go troubleshoot and fix that bug that only happens in production without jeopardizing production. And when you're done, we turn down all those nodes for you. AKS is an amazing offering for Kubernetes if you want to run it in the cloud. To learn more about Azure, or actually anything Microsoft, just go to docs.com. That's going to take you to a landing page where we can get documentation on everything inside of the Microsoft ecosystem, specifically Azure as well. So there you can drill in and learn about all the different services that we have, the resources that we have, how to spin them up. We'll give you architectural diagrams. We'll give you quick starts. Within 5 minutes, you can have new resources actually spun up in Azure that you can start to use. I find that Docs is amazing because it's also open source. So if you find something that's missing or an error, you can go to our GitHub repository, fork the repository, and send us a pull request, and you can see your changes live in Docs. We've also localized Docs. It's an enormous number of languages that you can use, so no matter what language you speak, you're going to be able to have a really great first-class experience in Docs. So no matter what it is that you want to learn about at Microsoft, just go to docs.com, and you're going to be met with all the value and information that you can possibly want.
Hi everyone, welcome back. So for those of you who did not get the chance to see Barbara just before, you just missed an amazing talk. So just come to the replay. But for now, we're going to talk about Maxim. Hi Maxim, how are you?
Hi Alexia, I'm good, thank you. How are you? How's your event going?
Well, great for now. And since you're here, it's gonna be greater. So I heard that you were in Microsoft too. So what do you do in Microsoft?
I do developer engagement for Microsoft Norway. That means I love to talk with developers, and I'm a developer myself. And my today's session will be about development.
Nice. So how cold is it in Norway right now?
It's not that bad. I believe like 15 degrees Celsius, something like that. So it's a nice autumn.
Oh, that's only stereotype then.
Absolutely.
Well, I'm going to let you talk about the web front-end developers since it's your thing. And thank you very much for being here. And the floor is yours.
Thanks for having me. Let's start. Yep. So today I'm going to introduce Azure Cloud for the web front-end developers. If Microsoft's general mission is to empower every person and every organization on the planet to achieve more, we can easily apply this to Azure, that is empowering front-end developers to achieve more with less efforts. And let me try to confirm that. About myself, I'm Maxim. I work in Microsoft Norway. I do developer relations, and by the way, let's stay connected on Twitter, where Max are you? I post mainly about awesomeness of web front-end, progressive web apps, and all things around, and also cloud, of course. And I built web since late 90s of last century. So I'm web front-end developer for 20 plus years, and I'm big fan of developer communities. I'm big fan of events like this. I organize meetups, conferences myself. So huge kudos to organizers of this virtual Azure Community Day. And yeah, I do lots of technical speaking, blogging, training, and one more side of my personality. I'm not sure it's dark one, but just to show some contrast, it's very personal. I'm a hobbyist DJ and music producer. Why am I ever talking about this during this session? It's very well connected because I realized that I really miss one simple tool for me as, let's say, creative DJ who produces music on the fly and want to mix this with some existing track. I just want to have at least rough understanding of the tempo of the track or I produce on the fly, or BPM, beats per minute. I couldn't find simple enough, free, stable tool for doing this online real time. So I built the one myself, and since I'm a web front-end developer myself, I used web front-end platform for making this, and it's purely web front-end based. It works in any browser on any modern platform, and there is no backend to detect this BPM value. It's purely happens on the client side in the browser. By the way, I'm super excited by the level of web APIs these days and what JavaScript can do and what browsers can do. Okay, I have this tool. I created this. I even gave it a name. I call this BPM Techno, and I registered a hostname domain for this. And by the way, it's progressive app. You can install it as a first-class citizen of your operating system, and it will work offline. But what next? So it's somewhere on my local host. It entertains me. It makes me happy. And I definitely want to share with the community. So I decided, what's next for my tool? I want to share this with the global DJ and music producers community. I don't want to keep it for myself only. And I have some features on the roadmap of this application. So now it's super simple. It just only calculates BPM and you can send feedback. Was it correct or not? But maybe I want to organize simple user account where you can have some stats on the music you played. It's interesting, how often you use this or that tempo. So something I can add and I want to add later. And with all these big plans, I still want to focus on web front-end development. I want to write JavaScript code, and I don't want to learn too much and too deep around other technologies, which will help me with this what's next bullet points. So I decided to explore what cloud can bring to the table, and I defined set of requirements for myself, and I believe these requirements are very applicable to majority of web front-end developers, either personal developers or the ones working within front-end teams. So these are quite obvious and quite basic requirements. So about the hosting itself, no doubt, it should be fastest on the market. It should be super reliable, like with close to zero downtime. Then we talk about global DJ community, and I want my application to be deployed as close as possible to these persons on the servers in their countries or at least continent. Then, if we talk about front-end, modern front-end, many of the applications these days are either SPA, single-page applications, or server-side rendering, and there is some extra support from web server side needed to properly maintain these technologies. So I definitely need to be all this stuff to be included. As I mentioned, I already registered custom domain for myself, so I don't want to have it on some random address. And of course, these days it's all secure, right? I really do not trust websites which are under HTTP, not HTTPS. So it should be included by default and enabled by default. Then about deployment itself. I really want to focus on the development. I don't want to spend any single minute on doing DevOps things and learning too deep this technology. I'm web front-end engineer. Maybe one day I want to learn about DevOps engineering in details, but not today. So I want to have the full deployment cycle without DevOps skills or deployment skills or ops skills. And also, I mentioned that I need some helpers. And if we talk about simple backend, for example, as I mentioned, I created one endpoint to provide feedback, was BPM detected correct or not. Then I mentioned that I want to create a user account, and it invokes the whole set of questions about identification, authorization, authentication, etc. I can implement everything manually by hand, right? Just implementing all these protocols and standards. But if there is a helper, I will be super happy. And plus, I want to have possibility to develop, to test, to debug everything locally on my machine. Even if you talk about the cloud, even if you talk about helpers for API and authentication in the cloud, I want to have the same environment locally on my machine. And last, but definitely not least, this is my personal project. I don't want to invest dollars into this. I invest my spare time into this project. And it would be cool to have a free tier, which is enough to at least start, at least deploy my application, at least make it available for the global community. And then we'll see if it becomes super popular with billions of visits. Maybe I will switch to the paid one. And you know what? There is a service which ticks all these checkboxes. Yes, of course, it's Azure Static Web Apps. I'm happy to be a mini contributor to this service. I provided my feedback on architecture and on some UX features of this service, which is now officially my favorite part of Azure. Okay, enough words. How to start with this? It's that simple that I have only one single slide on that. Two main options: either install corresponding VS Code application or just go to Azure portal and create corresponding resource. The creation itself is not more complex than pointing to a particular code repository. And these days, every project, including front end, of course, is in this or that source code repository. So this is not something outstanding in terms of requirements. Then you provide literally 2-3 points of the configuration just to explain better how your application is organized. And this is just about providing some folder names where your application located, where the build is located. Super simple. Then you count 3, 2, 1. And your application is online. Yeah, of course, if your application has sophisticated build flow, maybe this will be not 3 to 1, but 4 3 to 1. But still, after you pointed to the repo and provided simple configuration, no actions from your side needed. Your application just will be online, hosted on the test subdomain, which Azure Static Web Apps gave to you for free. And then we deployed the first version of the application. What's next? I have my next version, right? I added some feature, I fixed some bug, I added a couple of new bugs. What will it take for me to have the version I have locally distributed globally over the world? Again, it all happens automatically, this geo distribution. Well, point number one. You build your code, you push it to the source code repo, for example, GitHub. And you know what? There is no point number two. It's just there. You don't need to perform any other actions at all. I really love how that works. Of course, under the hood, GitHub and Azure process many things for you. So first, after you merged your new code to your main branch or branch you track using Azure Static Web Apps, GitHub starts the workflow as a part of GitHub Actions, and you don't have to have any knowledge about about GitHub Actions, about workflow file configuration. It created automatically for you. If you wish to learn about this, you can always dive deeper and explore how that works. Maybe you want to do some fine-tuning later, but not for the beginning. You just don't need it. It just works out of the box. So GitHub does all this build stuff. You hopefully provide it in package JSON, and before building your application, it carefully reproduces all the environments, like a virtual machine, it installs npm modules, etc. So just fully reproduce environment on every time you push your new code to the repo, and then all your static artifacts, index.html, your build CSS, your build JS magically becomes distributed over the globe. And by the way, if you prefer Azure repos and Azure pipelines to corresponding GitHub services, that's also possible to set up. And next, how to develop this locally. I mentioned that if we talk about a bit more complex pieces of your application, like API endpoints and authentication, some helpers locally are needed. And we have this helper. It's called Azure Static Web Apps CLI, command line interface. I strongly recommend you to install this. First, you can definitely develop your static apps without this, but to again, to reproduce sort of cloud environment on your local machine, this is absolutely necessary tool. You just go and install it. It makes sense to install it globally, so you have SWA as a new command available in your terminal, and then you provide a few parameters, and you have full environment running on your local machine. For example, these are parameters for a generic React application created by CRA, Create React App Utility, and this is what I actually use locally myself. I think it's time for demo. I bet you want to see how my application looks like. Yeah, let's spend 3-4 minutes on the demo, and I'll show you some extra awesome things, and then we'll go back to the slides where I'll explain how to continue learning of Azure Static Web Apps. Okay, I have the demo ready for you. This is application itself. You see it hosted on bpmtech.no. I really love this domain name, and yeah, I really want to show you this app in action. So I start listening, and before that I provided access to the microphone, and you see we can clap, and it listens to this. Of course, this is quite random number because this is not music, but I have YouTube with my own music. Yep, and this is correct BPM 120. That's exact the one I used when I produced this this track. So that works, and we can provide the feedback. Yes, this was detected correctly. Now, here is the repo of this application. Of course, it's open source, and you can check all the details of the code, how I created this. We have only a few minutes for the demo, but you can always refer to this repo where I explained step-by-step guide on demoing all the functions, and it includes automatic deployment on code change. It includes Azure functions, how to add functions, how to test them, how to provide proper routing for single-page application, and how to build authentication. Yes, all the main things are here for you to follow. This is how application looks in Azure portal. I call this BPM counter, and this is resource of kind Azure Static Web App. Of course, you see that I attached custom domains here. It easily can be done using corresponding plane on the Azure portal interface. And maybe let me demonstrate you one particular feature called staging environments. And just imagine, I created new version of the application, but this is, let's say, beta version or maybe even alpha version, and I'm not sure that I want to have this in on my main address because it needs some extra testing and maybe some extra feedback. What do I do? What do I do as a web front-end developer? I create a new branch, right? And I want to share this branch with maybe my peers, my friends, and after all, I want to have this branch hosted somewhere for end-to-end testing, manual or automatic. How Azure Static Web Apps can help us? Super simple. You create new branch, you push it to the repo, but do not merge. You just create pull request, and then Azure Static Web Apps automatically creates a new environment for you, new staging environment with new address. So you see, I have one pull request open. I call this new feature. And right after I opened this pull request, Azure Static Web Apps added a couple of comments, one comment here. Your stage site is ready. Visit it here, and I can open this and see how that looks and works. So you see, I just changed the background, and maybe I'm not sure that I want to put it into production. So what will happen if I still decide to have this black background in production? I click merge, and that's it. The Azure Static Web Apps will automatically swap the slots. And by the way, here how it looks in Azure portal. You see environments, and this is the one which was created automatically for me. If I decide to not go for this change, I just close pull request, and yeah, I can delete this staging environment. Okay, so this was a demo of the application itself and one particular feature. There are many more. Please find it on my repo. And now I want to go back to the slide, because it's super important for you, for me to share with you how to continue learning about Azure Static Web Apps. First, we have awesome resource called Microsoft Learn, and you'll find easy to follow step-by-step guides on how to introduce this or that feature of your application there. Of course, we have fully featured documentation on this service where you find all single details about every single piece of functionality. And my GitHub repo, you'll find also all the instructions with illustrations and my tips and tricks for you. On that, thank you very much, and let's stay connected. Let's stay connected on Twitter and LinkedIn.
Thank you so much, Maxim, for your nice talk. I have some questions from the audience. The first one will be in 2 words. What are the advantages of an Azure Static Web App compared to a classic Azure App Service?
This is a very good question. And in 2 words, you don't have to spin up web server yourself. So it's done for you, plus contains tons of other useful features, which are not part of, let's say, classic app service on Azure. So that this service was created specifically for static workloads. When you don't need backend, or your backend is simple enough to be Azure function.
Okay. Well, thank you. The second one would be, I saw that you have like a little project on the side. Could you tell a little bit more about the generous free tier?
I don't want to go through all the options we have on free tier. I can say that it's enough to comfortably host your personal and hobby project. So it's generous enough for you to show your application to the world. We can formulate it like this.
That's the elevator pitch. And the last one would, as everything seems to be packed and ready to go to be used out of the box, are you still able to do some advanced scenarios like managing secrets with a key vault, setting up a CDN or a Pamplemousse or a cache service like Redis to work with the static web apps?
Very good question, and here we have to go a bit into details. Key Vault, yes, it's ready for you. You can service it. You can use this service, and CDN and caching. Let's say it's automatically created for you. It's automatically distributed globally. You don't have to provide any configuration or any extra options. I believe if you really want to go deeper, maybe I can recommend to set up some extra serve like Azure front door in front of static web app. But to be honest, I never experimented with this myself, because what I receive out of the box is more than enough for myself.
Okay. Well, thank you. Maybe to finish this talk, if you have one message to provide to all the front web developers watching you, what would it be?
Yeah, my dear front-ender peers, please do not ignore Cloud. Cloud brings lots of fun and simplifies your work.
Well, that's the peace talk. Thank you very much, Maxim, for being here with us from far away. That's been a pleasure to have you in the VACD, and stay tuned if you want to see the next talk.
Yeah, will do. Thanks for having me. Have a nice day.
Thank you, Maxim. Bye.
Hi, I'm Leslie Richardson from the Visual Studio team. In the past few months, we've released 3 preview versions of Visual Studio 2022 that give you the power to personalize and be more productive in your development environment. Now, I'm super excited to share with you some more awesome features that are now available for Visual Studio 2022 Preview 4, which has just been released, so let's go check it out. One cool new feature that we introduced back in earlier previews of Visual Studio 2022 is Hot Reload. And in Preview 4, now we've added Hot Reload support for Razor files. So now if you're making changes to your C# code in a Razor file and you hit save, all your changes will automatically take effect in your ASP.NET application without having to manually recompile. We've also added hot reload support for CSS, and in this scenario, you don't even have to save your updates to immediately see them in action. Once you add your changes and the CSS file is syntactically correct, your program will automatically update with those changes whether you chose to save or not. In this example, I've got a basic HTML list of numbers that I want to convert to a grid format. So all I gotta do is paste in the related CSS and voila! My app is automatically updated with hot reload. Performance is always a top priority for Visual Studio, and Find in Files is one tool that we've improved performance for in Preview 4. So if you've got a huge project in Preview 4 that's got hundreds of files or even thousands of files that you'd like to search through using the Find in Files tool, you can see results up to 3 times faster than in previous versions of Visual Studio 2022. All right, so as a Visual Studio Debugger fan, I am very excited about the highly requested addition of dependent breakpoints that are now available for Preview 4. Dependent breakpoints let you enable a specific breakpoint only after another breakpoint is hit. So if you've got a section of your code, such as a game loop maybe, where you'd like to enable a particular breakpoint but only under a specific circumstance, but are unable to use a conditional breakpoint because you want to trigger the hit from either another page or a controller or something like that, dependent breakpoints are definitely the way to go. Now this last feature is for all the C++ developers out there. One of our goals for Visual Studio 2022 is to make it easier for C++ devs like you to build, test, and debug your cross-platform supported programs. Specifically, Preview 4 now makes it easy for you to target the Windows subsystem for Linux, or WSL2, by using the F5 dropdown, where I can select WSL Debian, for example. From there, I can run my program that will print out an ASCII cow, and the output is moved, from Linux to Visual Studio, as you can see here. So as you can see, there are a lot of really neat additions to Preview 4 of Visual Studio 2022, and that's not even the half of it. So if you haven't already, be sure to download Visual Studio 2022, try it out, share your feedback, and happy coding.
Hi everyone, it's me, I'm back. It's 3 p.m. in France and the weather is nice. So we've talked about DevOps, we've talked about GitHub, we've talked about web front development. What is missing? Azure security. So I am pleased to introduce to you Sergey, that's going to talk about offensive Azure security. Hi, Sergey.
Hello, Alexia.
How are you?
I'm good. The weather here is not. Pardon?
Go ahead.
Maybe weather here is not that good, like in France, but I'm good.
Where are you based?
I'm from Russia, and it's still warm but quite windy. So I'm afraid to go out, but I need to pick up my son from childcare right after the session. So
the winter is coming, Sergey. The winter is coming.
Yeah, I guess.
So I heard that on your session, Eyes, you said that you were an ethical hacker. What does that mean?
It means that I like to ethically, I mean legally, work as a hacker and try to find vulnerabilities and misconfigurations. So I'm not just talking about security, like how to make it better, but first of all, I can find the weaknesses. I'm trying to find weaknesses, misconfigurations, not perfect configurations, and show it to you, like, hey, that's how things may be broken by the real attacker. So don't do it. That's what you're gonna see in my session, by the way.
Nice. Well, that's a cool hobby.
It is.
I'm going to let the floors to you. And thanks for being here, and see you at the end of your session.
Sure. Thank you. All right. So, and hello to everyone. Let's get started. To be fair, I have so many things to discuss with you. And by the way, in this session, I mentioned that I'm going to show you different things, how Azure services, not the service itself, but your application, that service may be compromised if you not configure it optimally, not configured securely. And I'm going to show you those configurations. And that session will be based on demos. I'm not really a big fan of slides. You will not see a lot of slides here. Most of the time, there will be live demos. Also, by the way, many things I want to discuss with you, many things I want to show. So please ask your questions during the session. So in the end of the session, I will handle them, but I just want to make sure that we will have questions already. So because if I in the end, if I'm gonna say in the end, like, hey, now you can answer a question, ask your questions, then it might take additional time for you to write your question and so on. So make sure that you did that before we reach to the Q&A part. All right, so just one slide about me. Sergey, ethical hacker instructor, conference speaker. You may find me on LinkedIn if you wish. Microsoft MVP, Azure Hero as well, OSCP, and many other certifications. I can talk about myself for a long time, but we have very limited time, so let's get started. So that's my agenda. And you may say, what the hell is that? Like just 3 figures? Is your agenda? Yeah, so that's the 3 environment I'm going to compromise. I'm going to show you how they may be compromised. First environment is hybrid Active Directory. So when we have on-prem AD integrated into the cloud, so how things may go wrong there, what may be not configured properly there. And by the way, all of those environments are from field. So I saw that in the real world. And I just create a session based on all of those findings. Next one, virtual machines. So we will move to the cloud, and then I will show you how we can get into virtual machines. And finally, web application with Azure SQL. So that's going to be application using PaaS services, so App Service, Azure SQL, Key Vault, and so on, and how things may be not configured properly there as well. All right, so without being said, let's get started. First scenario, and as I mentioned before, you will not see many slides here. Let me jump right to the demo and quickly show you some things about that integration between on-prem AD and the cloud, and then what may go wrong there. So when we want to integrate our on-premises Active Directory, and most of the companies do that, when we want to integrate them, we install a tool called Azure AD Connect. So this one, Azure Directory Connect. And one of the interesting things during this installation, you must configure an account called AD Forest account. So during this wizard, you must create an account that will have permissions to have access to local AD. So for example, to read your local accounts, to read your groups. So it must be an account that will read your directory. And this account may be created automatically. That's the recommended option. So this one, which is the default, or you may pre-create this account yourself. The first one is more recommended. So let me jump to the main controller and show you where this account may be found. So here we go. MSOL _ and something. That is my account created automatically. I don't know password for this account, so the password was not revealed to me because it was created automatically. I'm going to go to properties. And let's check permissions, so group membership. So if I check member off, it's just a domain user. So looks like no problems. But what more we know about this account? If you add more configurations, if you add more features during AD Connect configuration, this account will have more permissions. So for example, very popular feature and very recommended by Microsoft, password hash sync. So it means that you will not only create users in the cloud, the same users in the cloud with the same names, but also they will have the same password. Of course, password hash, but whatever. The password value will be the same. So if you enable this feature, which is very popular and recommended, what will happen? Account will have extra permissions. Replicate directory changes and replicate directory changes all. Let me show you that. Let me show you those permissions. If I go to properties of my domain security and find MSL, and here our permissions are replicate directory changes and replicate directory changes all. So I know I have so this account has permissions. Now, if I can somehow compromise this account, I will get those permissions. Why do we need those permissions? You will see later. But let's first find a way to compromise the account itself. I'm going to jump back to AD Connect. Cancel that. So I don't know password for this account, but who knows the password? Someone must know the password, and this password will be stored in the AD Connect database. So if I open the database and let me find tables, and here's the table called Management Agent. Let me just select all of that from that table. Remove columns I don't need. Let's run that. And where is that? I think it's too much. Oh, here we go. So here's account. Here's the username. And here is parameter password, which is encrypted. All right, so I know that account is, and the password is stored somewhere here, but it's encrypted. All right, now we should find the answer. Who can decrypt the password? And the answer is local administrator. So if I go to computer management, go to local users and groups. So local administrators or AD sync administrators, they can decrypt this password. So that's the first misconfiguration we usually find is when AD Connect administered by middle level administrators. What may happen in that case? Let me show you. So let me decrypt this password. I may do it manually, but it will take a while. I will not have enough time even in this session. But there's a tool called AD Connect Dump. Very easily may decrypt this password. So let me run that. Look at this. So I have a username and I have this crazy long password. So let me copy this password and go to different machine. And I'm going to open CMD. Run as administrator here. By the way, I'm a local admin here on this machine. That's normal. If I'm a local admin on the server, I can be a local admin on the client machine as well. So I'm going to copy the password and let me type username as well. Click OK. So that will take some time before this account will be able to open the command prompt. But let me first check this command prompt you already see on the screen. Who am I? User Jada. If I try to check access to the main controller C drive, it says access is denied. So user Jada doesn't have access to the main controller. It means that this user is not the domain administrator. All right, so another command prompt appeared. Let's see, who am I? This time I'm MSOL. Let's see if we have access to the main controller. No, we don't. All right, but what we can do if we own a MSOL account, let me show you this real quick. I'm gonna open a tool called Mimikatz. And here I'm going to use a command of this Mimikatz called DC sync. The idea of DC sync, if you have permissions, of course, only if you have permissions, you may replicate information about any user in your domain. So I have permission to replicate, right, from my MSOL account. So I will replicate information about trainer who is domain administrator. Let me try to do that. And look at this. I have NTLM hash of this user. What I can do with that, So let me go back to another command prompt, open Mimikatz. And I'm going to use a command called pass the hash. Very well-known thing. I don't think I need to explain that. So when you may use hash instead of password. So another command prompt opened, the third one. Let's try to list C drive. Yay! I have access to C drive of the main controller. So that means I was able to compromise a local AD and using AD Connect. And from here, I will be able to, I think I will be able, we'll see, I will be able to move on. But what we already did, we compromised local AD and AD Connect as well, using AD Connect. Now, next scenario from here, sorry, I will move really quickly because I have so many things to show you. In the second scenario, we will continue our journey. And this time, I have virtual machines in the cloud, in Azure this time. I deployed Jenkins on 2 virtual machines, Linux and Windows. It doesn't really matter if it's Jenkins or something else, just the fact it's Windows and Linux. So let me jump to the portal and show you those machines. Virtual machines. So Jenkins master, Jenkins slave, they are here. So maybe I can connect to them. I don't know. I just have access to local AD. I don't know about anything about cloud. I can't even find this information because I don't have access to the cloud at this moment. So first of all, I must gather information about the cloud. How can I do that? Let me jump back to demo. And so let's continue our let's continue to from where we left off. So now I'm domain administrator. If I'm a domain administrator, what I can do, I can connect to any workstation on my network, right? So that domain admin can do almost everything. And let me show you a few interesting moments. If I open CMD on one machine and type something like list VMs, so I just want to list VMs using a tool called AZCLI, and it should show me the list of VMs. Yes, I can see Jenkins here, so those VMs are listed. Let me open CMD on another machine, and list VMs here as well. And this time it should fail. So please cross your fingers. Yeah, it says you must type AZ login to list VMs. All right. So, but I didn't do anything here. I just opened CMD and type my command. But here I must type AZ login. The reason why, when I type AZ login for the first time, token will be cached locally. So if I go to my user profile, look at this. There's a folder called .azure, and here is token. So what I can do, I can take this token. Oh, I already damn it. I already zipped that. So let me copy this token. And if I transfer this token, if I copy this token to another machine, let's do it real quick. Extract that. And fingers crossed, now I should see the list of VMs. Come on. Yay. So now I can see that I can enumerate VMs, I can find more information about them, I can find IP addresses, their IP addresses, and so on. I can even download the information for connectivity. All right, so now I'm in the cloud, and now let's explore those machines a bit more. I can see that there's one machine on Windows and second machine on Linux. They have public IP addresses. I kept that. Not necessary, but I have it. And if I want to connect, let's try to connect using RDP. Let's say connect. Let me just copy IP address. And let's say MSTAC. Look at this. They asked me for password. So if I want to connect to virtual machine using Windows or Linux, I must know the password, or maybe in case of Linux, I must have a key for connectivity. I don't have it. I don't have password. I don't have a key. So I don't have a stage key. So I want to find some other way to connect without using a password. So and there's a way how we can do that using what's called run command. Let me click run command. And so if it's Windows machine without any usernames and passwords, you may run PowerShell script inside of the machine. If on Linux, that's going to be bash script, shell script. So let's try that. So what I can run? Of course I can run some native. I can run some commands like who am I, ipconfig. But what I can also do, I can run something like reverse shell and try to get into the machine. Let's do it for Linux. Fingers crossed. And let's do it for Windows as well. So on Windows. So that takes some time before all of this. Oh, look at this. I'm in Linux. And I'm root, because all of those run commands, they work on behalf of the most privileged user. So root or system, depends on which operating system you have. So I'm inside of the Linux. And let's see about Windows. For Windows, it takes a bit more time. Oh, looks like something happened. Yeah, I'm in Windows. Who am I? And I'm NT authority. So what I can do next, I can read error log of Jenkins, and I should be able to find initial password there. Should be, if I scroll all the way up, here's the initial password. Let me copy this. It doesn't really matter what I'm doing, what I'm going to do next. I'm just want to show you that I can connect to Jenkins with this password. Of course, Jenkins may be configured with a new username. I didn't. I just used the initial name. If port for port 8080 Jenkins, that's the right port. Oh no, that's port is closed. Anyway, so who cares? I think it's 8080 for Jenkins. I didn't open the port. Anyway, so I'm inside of the Windows and Linux machines, and so that means I compromise those two machines. And yep, that was the second scenario. And from here, let's jump to the last one. I know I'm going really quick. Maybe for those who are not. For you, it's hard to take a breath because it's very fast. I also want to reserve some time for your questions, so let's continue. I hope the last scenario should take a bit more time than others. All right, the last scenario where we have web application and SQL database. So I have app service, and SQL database as well. So app service stored data in SQL in the SQL backend. You know that web application connects to database, it must have credentials. And credentials may be hard-coded on the web application, but that's a very bad practice. So what I'm doing, I'm using Key Vault to store credentials there. So web app will use credentials from Key Vault as a secret, stored as a secret in Key Vault. And also, what we should have, which Microsoft recommends, is to rotate those credentials. So, idea is you have the special function application, and this function application will have few functions, and they will rotate secrets in Key Vault, and at the same time will update passwords in SQL and on the SQL server as well. That's the rotation. All right, so it looks pretty solid. So how can we try to compromise that? I don't want to say I see it every day, all day long, but sometimes we found that companies, they may have Key Vault properly configured, but the function for this rotation had different permissions. So if I don't have access to Key Vault itself, but I have access to function, I can try to compromise the function first, and on behalf of this function, get access to Key Vault. So let me jump back to demo and show you first my Key Vault and function, and then we'll try to compromise that. So first of all, let's go to Key Vaults. And here's my key vault. Go there. Let's go to secrets. And it looks like I don't have any permissions, so I can't list secrets. So this user doesn't have permissions to list secrets. Let me quickly show you that secrets exist. If I add access policy, let's say secrets. I just add permission to list, and let's add myself. Let's click add and save. And secrets. Yeah, we have 2 secrets: username and pass. Username, pass. All right, let me remove this permission. Save that. And let's take a look on our function application. So that's a function application from Microsoft website, from the GitHub, which you may find from Microsoft from docs. Let's go to functions. And here's the function AKV storage rotation HTTP. So it means that it will the trigger for this rotation will be HTTP request, and that is based on PowerShell. So I can find. Come on. So it's a PowerShell based function. All right. So what may go wrong here? First of all, permissions. If function has more permissions than key vault, what I can possibly do? And another one. By default, functions, they have FTP enabled. What I commonly see, companies, they do not disable FTP. They don't use FTP, but at the same time, they do not disable it. So FTP is enabled. They use, continuous deployment, but they still have FTP turned on. And so look at this, FTP state turned on. That's by default. Now, if I have permissions, I can extract credentials for FTP. FTP credentials, they're here. So let's do it from command prompt. I'm gonna open FileZilla, and let's extract credentials from FTP. So first, let's find the FTP URL for this function application. So here's the FTP URL. Copy that. Paste this. And I also want to extract credentials. So here's the username. And password. What the hell? All right, that's better. Now, look at this. There's a side. Let's go to www, and look at this. That's my functions. I can go there, and what I did, so by default, it was run.ps1 from Microsoft, from GitHub. But what I did, I renamed that to run1ps1, and I add my own script. This script will extract secrets from Key Vault and show it to me. So what I want to do, I want to run it. I just want to say, I just want to send HTTP trigger. So let's run that, and that will take maybe 30 seconds, something like this, before I will find that username and password. So in parallel, let me go back to slides. So now I should get credentials from Key Vault using this using function. And now if I get credentials, I can try to connect to SQL backend. So that's going to be my next step. And let me open SQL Management Studio here and another machine as well. So SQL Management Studio here as well. And let me copy this paste here. Oh, that's not what I want. Copy, paste, no, paste. All right, so let's check my PowerShell. Here we go. Look at this. Username is web app, and password is PASSWW0RD. Let me paste it here. Web app. Oops, Didn't work. It says when you try to connect this to the SQL server, your IP address doesn't have access to the SQL server because of the firewall. So you must create a firewall rule, and so you must sign in with the appropriate permissions and configure firewall. So let me now jump back to Portal and show you the SQL server. Show you the SQL server. Oh, by the way, in parallel, what I want to do, I want to open application because this SQL server, I'm trying to save money. So this SQL server in idle state. So let me just open this. Let's go back to SQL. So let's click firewall. And look at this. There's no IP addresses. It recommends me to take my IP address to whitelist that, but there's no IP addresses whitelisted. But I can see the configuration, which is very, 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 very common. And many companies configure it like this. Allow Azure services and the resources to access this server. And what companies think about this, like if they enable, if they say yes, then resources they deployed in their Azure subscription will have access to the SQL server. So they will bypass firewall. It's not really true. If you say yes here, it means absolutely any IP address belongs to Azure will be able to bypass firewall rule. So another company from another country, from another region will be able to do the same. Of course, they must have username and password, but they will bypass firewall. So this configuration not very optimal. Let me quickly show you if I'm going to a machine in the cloud and just type this password, click connect. Yeah, I can connect. So much better solution here is to what's called deny public access. So in this case, you will not allow connection from outside, only using virtual network. So let me save that. And now public access is denied. Wait a second. Why are you not still active? Huh. Let's try the refresh. So now let's jump back to slides. So now access. Oh, let me show you that what will happen if I try to connect. Let's try to disconnect and connect again. Type this password. Oops, access denied because public access is denied this time. All right, so what I can do now? Now the only thing I left with is web application. If I can compromise web application and connect the database through this web application, that will be profit. So that's the last thing that I have left. Let's jump back to demo as well. Oh, finally resuming. Now, so let me explore my web application first. I'm gonna go to app settings. Here is my web application, and web applications they have the same issue, not the issue, but the same specific as app functions. So FTP is enabled by default. And you may connect, FTP is enabled, and you may connect to application using FTP. So FTP is enabled, FTP state enabled. Let me try to connect to application using FTP. Let's copy that. Let's open new tab. Oh. Now let's get credentials. We are close. So let's just copy this username. Oops. And create a password. We are almost done. Yep. So, yep, we are connected. Now, that's I already pre-configured that. Let me just remove them. Now I can see that there's a one page in this application. So let's explore that. Let me just refresh that real quick. So it shows me that it's just one pager with registration form. Let's say I want to call that VACD, and email will be vacd@whatever.com. So let's click submit, and so that's fine. All right, now what I want to do, I want to get this information from database. For that purposes, first of all, I want to take control over application itself, and let me upload to this FTP one file with PHP, one more file, and let me add that in my URL. Yay! So it means I'm in. Oh, not die, dear. And now it means I'm inside of the app service. ID. Looks like it's Linux. Let's see. Uname. Yeah, it's Linux. Uname -a. Ubuntu. Yeah, Ubuntu. So I'm in Linux. That's the web shell. To be fair, this web shell is not the most robust way. So to have control. So let me establish the normal reverse shell. Now I have full reverse shell. And one thing I need to do, I need to have tool to connect to database. Tools must be installed using permissions of root. I'm not the root. So I need to have tool that may be used without installation. So that's tool called uSQL. It's free tool, and you may just upload that without any installation. And let's try to use that tool to connect to database. Let's try to connect. And let's list tables. Table called registration TBL. That's where where it stores information about registration. So then let's try to take a content. And now we can see here, here's VACD whatever.com. All right, so finally, I was able to get information from all of those parts. One last thing, very quickly, without demos, what we can do with all of this. So we have, looks like I have 6.5 minutes. Hopefully you have your questions ready, so we'll not spend too much time on that, on the waiting of that. Let me quickly, in 2 minutes, tell you about mitigations. So first of all, if you want to protect your AD Connect, you must keep in mind that it must be administered by domain administrator. Do not allow middle-level administrators have full access to AD Connect. Yeah, I know the logic, like, oh, AD Connect not domain controller, so domain admins administer only domain controllers, and the AD Connect is not domain controller. You still should allow access only to domain administrators to AD Connect. Next one, about cached credentials. First of all, you should have the separate workstation for administration, so they will be better protected. And also what you can do, you may configure token policies. I think there's a typo there, but anyway, policies. And so token will expire after some period of time, because by default it will not expire. Also disable FTP on functions and application, disable public access for SQL servers, and from web attacks, like if someone tries to run SQL injection or something like this, web application firewall. One last thing I want to show you here is about a web application firewall, is that I think you had discussion about that with the previous speaker. Something like, at least I heard that with one ear. So we have web application firewall built into front door or application gateway. And so what I did, I test that using special fuzzer called WAF Ninja, and it shows me like different malicious strings that may be sent to web application and how the application firewall reacts on that. On the left, you can see what was sent, and on the right, the result. And every time it was no, it wasn't accepted. So pretty good way to protect your application. All right, so now I think I have 4 minutes and 20 seconds or something like this, and I can finally handle your questions. So let's take a look if you have anything.
Well, thanks, Sergey. I can tell you that the audience is pretty scared by everything that you've shown. That gives us some feedback, I think, to to think about. The first one is does the integration of a third-party products like Kubernetes, for instance, make the security management more complex in Azure?
Kubernetes, right?
Yeah.
I have a separate session about Kubernetes, to be fair, Kubernetes. And on the Cloud Summit or Azure Summit was in September. They should have a recording about this. Yes. So containers and Kubernetes, that is, it's not only a it will not only add the technical complexity, but usually when you implement Kubernetes or something like this, it's like a part of DevOps process. And so that's like number of things you also must add into your life cycle layer, your pipeline. So yes, that will add a lot of complexity, not only on the technical level, but also on this, organizational level.
Okay. Well, the second one is, do you have any pre-built checklist or guidance to share with developers to help them cover the most common security mistakes? And I think you've shown some of it at the end. Do you have any other document that people could rely on?
To be fair, no, I don't have it combined all together, because quite often first I show them what that's first of all, it's usually part of assessment. So I analyze what's going on. Second, first of all, must find the vulnerability, must configuration, and it may be it might look a bit different in different environments. But the best thing I can recommend you if you don't want to run assessments from security professionals, Security Center has subscription called Azure Defender, and that may analyze your Kubernetes, tell you about your container registry. Maybe you're using outdated images with known vulnerabilities. And Security Center also may tell you about, if you didn't configure properly your network security groups. So it will not cover everything, but believe me, your company will be much better protected in that case.
So to advise the audience, what would be the number one mistake that you see usually, and the number one prevention that you could advise people to do?
The biggest issue I usually see is permissions, because I know it's very tedious, especially we're talking about developers, right? And any developer may say, hey, I'm a developer, I must have all permissions in the world, because maybe I need to do this, or sometimes something else. And developers, they have a lot of privileges, not only developers, because configure permissions properly and granularly, it's very tedious and boring, to be fair. And a lot of hassles about that, like, oh, I need permissions, please give me them, or give me more permissions, and remove permissions. So all of this, lot of hassles, and sometimes it means quite often, I would say, companies, they provide too much privileges just in case. So I don't want you to disturb me anymore, so here's your permissions and do whatever you want. And that's quite a common problem. And the only thing you can do here, first of all, is to create appropriate least privileges policies, and also use some extra premium features like PIM, privilege identity management. So you will be able to provide permissions on some time, for some short period of time, and then those permissions will be removed after this. Okay. So permission, that's the biggest issue.
Okay, the permission. Got it. Yep. Well, thanks a lot, Sergey. That was really interesting. Thanks for being with us from Russia. That's pretty much far from France, but the dev communities really appreciate it. So thanks a lot.
Thank you. Thanks. Thank you very much. Stay safe. And I'll go pick up my son.
Thank you. Bye.
Bye-bye.
I'm Charles, and in this video, I'm going to show you how to use watches and the immediate window in the Visual Studio Debugger to get a better understanding of what your code is actually doing. With these tools, you'll be able to rapidly test or debug any feature without having to add countless log statements, create custom debug interfaces, or spend hours running your scene over and over again. Let's get started. Some of the best game mechanics are the ones that the player doesn't even notice. Those subtle features like real-time difficulty tuning or automatic steering that improve the player's experience and make a good game great. Take this spawner logic, for example. On the surface, it works like any other spawner, instantiating enemies in the scene on a predefined interval. Except, I've tried to improve it by using an animation curve to change the spawn rate over time. Assuming that the x-axis represents elapsed time and the y-axis represents spawn rate, both in seconds, the first enemy will spawn after 5 seconds. Then, the spawn rate will decrease linearly until it reaches 1 enemy per second after 5 minutes. It's pretty straightforward, but allows us to create some pretty interesting behavior. For instance, we can actually add some keyframes and adjust them to ramp up and ease off the spawn rate, while continuing to create more and more enemies over time. Now, I'm doing this by hand, but we could actually write some code that adds keyframes dynamically in response to the player's ability to handle the current spawn rate. And that's the type of feature I'm talking about. One that uses sophisticated logic to enhance gameplay without the player knowing. Which is great, until you have to tune or debug your code. I'd like to test out a couple of different curves to see which one gives me the best gameplay experience. But doing so is going to be a challenge. Here, let me show you what I mean. Right off the bat, we can see that the spawner is working, and if we wait long enough, we'll be able to experience the entire curve and determine how it feels. This is fine, but I'd like to take a more scientific approach. Realistically, we're going to have to test multiple variations of this curve before we get it just right. And once we've done that, we're going to need to use that information to write logic that updates the curve programmatically. To do that, we're going to need better information to work with, some cold hard numbers. But how do we gather that data? One approach would be to modify our spawner so it outputs log statements that we could then analyze after we run each test. But there may be other components outputting logs as well, and it's hard enough to decipher the console as it is. Alternatively, we could write some on-GUI logic to create a custom UI for our debug data, which would allow us to create some pretty useful visualizations. That'll produce better results for each test, but we'll still need to take the time to run the scene for each curve, and that could take hours. There's gotta be a better way to do this, right? This is the script that handles all of our spawner logic. This function here is responsible for evaluating the animation curve in order to determine how long to wait in between each spawn. The key variables here are elapsed time, current spawn rate, and spawn rate curve. The script tracks the elapsed time in its update method, which this function uses to determine the current spawn rate. It does so by passing elapsed time into the animation curve's evaluate function. Evaluate returns the value of the animation curve at a given point in time. In this case, that point in time is elapsed time. Let's take a quick look at the animation curve in Unity to get a better picture. When we call evaluate, elapsed time represents some point on the x-axis, and the value that evaluate returns represents some point on the y-axis that corresponds to elapsed time. It's easy to see here on the graph, but unfortunately, this view won't be available when we start generating the curve programmatically. So we'll need a better way to gather this information. That's where watches and the immediate window come in. These tools will allow us to call evaluate on our animation curve over and over again with any values we want to pass in, which will make testing and tuning much quicker and easier. To use them, we'll need to start the debugging process, which we can do by attaching Visual Studio to Unity. And then setting a breakpoint that'll pause the execution of our code so we can start debugging. Again, watches and the immediate window will allow us to execute code while our program is paused. It'll even allow us to call functions on scripts that are currently in scope, which is why it's important that we choose where we place our breakpoints wisely. I'll expand more on that later, but for now, let's place a breakpoint on the line that calls evaluate and run our scene until the debugger pauses execution at our breakpoint. Alright, the Visual Studio Debugger has paused the execution of our code at our breakpoint. Now we can get to work. Let's start with locals. In our video on inspecting variables, we showed how the debugger window lets us see the values of any variable that's currently in scope. We can already see here in the Locals tab all of the variables that are important to us: current spawn rate, elapsed time, and spawn rate curve. However, we'd like to see values that aren't currently available to us, namely the result of calling evaluate on the animation curve at different points in time. We can do this in the watch window. Right now, our watch window is empty, so let's add some code by clicking on Add Item to Watch and adding a simple expression. Beautiful. We can see our expression, its value, and its type. But everyone knows that 1 + 1 = 2. So let's get to the real business at hand. I'd like to see how my animation curve evaluates at different points in time. So let's add some more watches. There. Now we can see exactly how our animation curve will affect spawn rate at key points in time, namely at 30 seconds, 1 minute, at the halfway mark, and at the end. And of course, we can add as many watches as we need. This is made possible because spawn rate curve is currently in scope. In other words, it can be accessed by the function in which we placed our breakpoint. However, if I had placed a breakpoint somewhere out of scope, say another script, we wouldn't have access to this variable. That's why it's so important that you place your breakpoint on a line that's relevant to the code you're trying to test. Now, what we've just done may seem simple, but we've actually accomplished a very important goal, and that is that we closed our feedback loop. Instead of having to run the scene and wait for these values to appear in the console or on some custom debug UI, we were able to evaluate them immediately. Our feedback loop went from hours to minutes, which means that we can test as many animation curves as we'd like. As a developer, you always want to be on the lookout for ways to make your feedback loop as short as possible, so you can get on with your work and move forward. Having access to this data is invaluable and will help us write more intelligent code when the time comes. But nothing can replace the actual feeling of playing the game and experiencing these spawn rates firsthand. That's where the immediate window comes in. Where the watch window allows us to view the results of arbitrary expressions, the immediate window gives us the power to execute code that'll actually affect our running game. We can still output return values of expressions like evaluate, but with the immediate window, we can actually change the value of elapsed time and experience the result firsthand. Here, we've changed elapsed time to 150, effectively jumping forward in time by 2.5 minutes. Let's test this out in Unity. Not bad. I think this feels like a good spawn rate, but I'll definitely want to test this curve out at different points. Just like watches, the immediate window only has access to methods and variables that are currently in scope, so you'll want to take care when choosing where to place your breakpoints. But once you're set up, you'll have the ability to test, tune, and debug any code rapidly and with ease. On the surface, these tools are simple, but when used correctly, watches and the immediate window give you an incredible amount of power over your code, and the ability to dramatically reduce the length of your iteration cycle. And the best thing is that they're both a part of the Visual Studio debugger. So, whether you're using Visual Studio for Mac, or Visual Studio Code, be sure to take advantage of these powerful, time-saving features.
And we are back. Thank you everyone for still watching us. If you missed the beginning, you can still go to the Mac TV channel and see the other way of it. So we've talked about security, but the second really important thing in Azure is costs and money. So welcome to BS. He's going to talk about money today. Interesting subject because cost estimation is main problematic for customers. So can't wait to see what you're going to show us. How are you, Tobias?
Hi, Alexia. I'm fine. Thanks. Doing good. The weather is good outside, and I'm happy to do my session. So not a lot that can go wrong.
Yeah, everything is great then. Well, we hope you're going to enlighten us on the security and the cost efficiency in Azure. So thank you very much, and the floor is yours.
Thanks a lot for the introduction. Yeah, so as you already said, calculating Azure cost is the topic for today, and I've added conveniently because that's the one important thing. To introduce myself quickly, my name is Tobias Fenster, as you've already seen and heard. I'm the CTO of the Cosmo Consult Group. I'm also a regional director and a Microsoft MVP. If you like what you're seeing today, if you want to follow more what I'm doing, then you can find my Twitter handle, my LinkedIn handle, and the URL to my blog down here. But let's get right started because we don't have a lot of time. What is the problem that I want to talk about today, or what is the reason that I looked into all of this? Well, if you imagine that you have a solution that is built on some Azure services, maybe with a constant part and a load-dependent part, and then you need to do different price calculation for it. For example, a small, a medium, and a large size. And then you also have different commitment types. So the customer tells you, or a partner tells you, I maybe want to do this pay as you go, or I might want to reserve this for a year or reserve it for 3 years. What's the difference in price points? What's the difference if we go for the small, the medium, or the large one? And maybe also what's the difference between using this as a dev test in a dev test subscription and in a production subscription, because there is different license price points for that. So it gives you an idea if you have a more complex scenario and then you want to start changing things to do comparison, it can become interesting. What I did before I had this tool in place, I used the Azure pricing calculator. You can see the URL here, and I'm pretty sure you've seen that one before. That, of course, is a great tool. It helps you to get a quick indication. It helps you to see all the different services, put them together, and get an idea. But if you have such a more complex calculation as I've shown you, and now you want to start changing things, it very quickly becomes annoying, because basically you need to open all those different configurations and make the changes, and then you decide, okay, let's say V4 or V5 of the Azure VMs has appeared for the types that I'm using. Now, what is the different price point between E4 and E5? And then I again need to go in and do all the different checks, do the different changes, and that can become very, very annoying in clicking and doing all of that there. So to give you an idea, the situation for me was like this. I had 3 configurations. I have 3 different commitment types and 2 usage types. So I basically have 18 distinct calculations. And I don't want to do this all the time in Azure because that's just too much clicking. And if I need to change this, it's even more clicking. I'm basically a developer. So yeah, I want to automate this. I want to make this easier. So what I created for this, and that's the thing that I want to prepare or present today, is a solution that is using the Azure Retail Pricing API. So there is an API that gives you the prices for the different Azure services. It's unauthenticated, so you can just get the results. It's very easy to get the first results, as I'll show you in a second in a quick demo. But then sometimes some of the requests need unusual queries. I've blogged about that, and if you want to see more details about the maybe pitfalls, I would suggest that you just check my blog post, because in the 20 minutes today, I won't be able to go into too much detail there. Okay, so we have an API, but of course an API is not enough, because you don't want to do direct REST calls, manual REST calls all the time. And I also wanted to have a place where I can store my configurations and just have different variations of that. So I put together my VM, my storage, my IP address, whatever I need for my service. And then I just say, now I want to have this pay as you go. I want to have it in a reserved variation, and I want to have it in a dev test and a production version. So that needs to be stored somewhere. The results I want to have also in a format that I can just later reuse. So it basically these days came down to storing something in JSON, calling a REST API, and then getting feedback in JSON. And that the obvious choice for a programming language is JavaScript or TypeScript. And as I was there, I always wanted to try Deno. And if you don't know, the logo that you can see here is the logo for Deno. That's a programming language and runtime environment, and also package manager. which is invented by Ryan Dahl, one of the guys behind the original invention of Node.js. And he basically said, okay, there are things that I regret about Node.js. If you want to watch a really cool session, that's the one I mentioned here. I think it's like half an hour and a very good tech session, very funny. So basically, I wanted to try Deno, and I took the opportunity to use Deno. So with that, I had my API. I had a tool to talk to the API and get results. But then again, I don't want to look at the results in JSON. At least I don't want to present them in JSON. So what I also did is I just imported them into Excel. Fortunately, that also has gone a lot easier in the past. Power Query that is integrated into Excel by now allows you to import JSON and transform it directly into Excel. And then you can get an overview. You can tinker with those numbers, like adding a margin or rounding stuff or things like that. And that's just also very easy again. And the last part that comes into play is that I put everything for development into a dev container. I'm a fan of having separated dev environments without polluting my laptop or polluting my development VM. So I just put everything that I need to develop or run a tool into a container. That's a great feature of Visual Studio Code, being able to use development containers. Unfortunately, Windows containers are not supported because otherwise that would have been my go-to. But fortunately, on Windows 10 and 11 through the Windows subsystem for Linux, there is very good support to run Linux containers as well. So yeah, that makes it very easy, as I again will show you in a second. So basically, this is my starting point to give you an idea. And now let's jump into the demos to give you a feeling of what it actually looks like. The first thing that I want to show you is the pricing API. And you can see here, I have a REST call, a GET call to that API. This is the base URL for the API, prices Azure.com API retail prices. And then you have to add a filter because otherwise you will get all the details here. And I'll close that one for a second. So what I want is a product that is called Virtual Machines EDSV4 series, and then I want to have the E4DSV4. If you're familiar with virtual machines on Azure, you will see, okay, this is a specific virtual machine size, and I can get the price for this. So if I send the request, it will take a couple of seconds, and then it comes back with the information. And there you can see, okay, now I have the information. It's always in US dollars. I have the price, I have the region, and I have a lot more information. And if I scroll down, you can see, okay, this is Japan again. This is Japan. Then we have the UK. We have, let's see, what's next, South Africa, and so on. So the second thing that I want to do is I want to further limit it into West Europe because I know that I want to run my workloads in West Europe. So it's just adding an AND ARM region name equals West Europe. I sent the request again. And the result now is only 3, as you can see here. So we're now limited to the ARM region West Europe. The only thing that we now have is we have the price for, as you can see here, consumption. So basically pay as you go. How much are you paying per hour, as you can see here? The second thing is reservation. And that's the cost for the reservation of 3 years. So I'm now, unfortunately, no longer getting the hourly rate, but I'm getting the price for the full 3 years. And then I also have pricing, as you can see here, again, reservation, but this time for 1 year. And we have the price for 1 year. So if I want to compare the different things, I decided to do it on a monthly basis. So I'm basically dividing the price that I get for 1 year by 12. So I know what the price for 1 month is. And I'm multiplying the price that I'm getting here by 730 because that's the average amount of hours in a month. Hours in a month. And that then gives me an idea what the monthly price there is. But those are the kind of things that my service is able to handle for you. And now to give you an idea how easy it is to compare different things, you've seen here we were on EDS v4, and I can also make a request for EDS v5. Need to change the product name as well. And now if I send the request, you will see exactly the v5 version is 50% cheaper. So I can compare those. What you can also see is that now I only get one result because for the V5 version, there is no reserved pricing yet. So I'm only getting the consumption pricing for now. But again, it gives you an idea how easy it is to change things and to make a comparison between different versions. So this is the API. A second step that I want to show you is the tool. Let me switch over here. So we're already in the right development environment. And I have a sample configuration here to give you an idea what that looks like. So I have two pricing configurations that I want to check. I could have also one if I only want one, but in that case, I want to compare two different ones. And that is the reservation for 1 year. I give it a description of reserved. We will see that later as well. The region would be West Europe. And then we have also the consumption pricing type, which later will appear as pay-as-you-go. I can also use this to compare different regions. If I don't add West Europe and West Europe, but maybe West Europe and Germany West Central, then I could do a comparison between the different regions. So I can play with those parameters if I want to have a comparison of the pricing there. Then I can define what the amount of hours per month is that I want to use for calculation. And I can define here what the exchange rate between US dollars and euros in my case is. So those are the pricing configurations. The other thing that I want to add is what are the actual resources. And there you can see here, if you're familiar with JSON, that is an array again. So I can have multiple resource configurations. And the first part is the virtual machines. So I have the virtual machine EDSV4 series. I have 2 of them. And then I can have a description that basically says what it does. For me, that's a base scale set, but you can add whatever makes sense for you to identify the different parts later. I'm not only using virtual VMs, I'm also using disks. So I have the OS disks here, and then I have data disks here, which are a bit larger. And you can see I always have 2 of them. And then because I need to pay for the license as well, I have Windows Server licensing here, which is a specific product as well. The E4DS-V4 are 4 CPUs, so I'm adding 4 CPUs here as well. I have 2 VMs, so I'm adding 2 here as well. And I'm adding optional true because those are only valid for a production environment. For a dev test environment, they aren't. So I can later make a differentiation between optional and mandatory, and that is basically the differentiation between dev test and production. And then I have a second part, which is the storage and the public IP. So I have some storage as well. I have an IP address, and I need to pay for those as well. I have those 2 different because the storage and the public IP for me won't change, but the other part will change in the different configurations. So if we are now already in a dev container, you can see it in the bottom left. It's slightly small. I hope you can read it. But this basically says it's running in a dev container that I call Deno. And now I can just hit F5. And it will launch Deno for me. And I immediately get an error. That's because I made a change here that I shouldn't have made. Sorry for that. Let's try again, F5. And now you can see, okay, it's taking a look at the file that we just looked at, the sample.json file in the configs folder. It's now talking to the REST API, to the pricing API to get all the different price points. And now it says done, as you can see here. And if we take a look at the files and do a reload, then the sample result JSON file will appear. And I'll try to format that one so it's slightly easier to read. So now you can see we have the VMs part in the reserved variation in West Europe for a 1-year reservation. And then I see the monthly pricing here. I can see whether it's optional or not. And you can see the descriptions of before. And then I get a total pricing for the mandatory parts, and I get a total pricing for the optional parts as well. Then we have the storage and the public IP in the reserved variation. We have the VMs in the pay-as-you-go variation, and we have the storage and public IP in the pay-as-you-go variation. So I basically now have my 4 different configurations all set up, and I can use those files as well. The result in Excel, then, if I do some importing and tinkering with Power Query, is like this. The first part is that I can have a total pricing. That one is for the VMs and for the storage and a public IP address. And then we have the pay-as-you-go pricing as well for the storage and the public IP address. So this gives me an overall pricing per month. And then I can also take a look into the details over here. So I can see, okay, the VMs here consist of the basic scale set, of the operating system disk, of the data disk, and of the Windows license. And I can see the detailed pricing here. And the storage and the public IP address, I can see also the detailed pricing here. So it gives me a chance to drill down into all of that. Now what happens if I want to make a change and want to do an update? To just show you that as well, I'll copy that file. Let's say I want to have a small configuration. And in this case, I'll go for a E2DS. That one only has 2 CPUs. And let's say the data disks are also smaller here. So we'll do that smaller as well. And that's it. If I hit F5 again, it's now, oh, sorry. I need to tell it to use the small configuration. That was exactly the change that I did before. So let's stop that run and try again. Now it should say exactly, this is the sample small configuration. Now it's doing the same backend calls. It's collecting the same kind of data, but now in a different configuration. And if after a couple of seconds it returns, let's go in here, do a refresh. We have the result here and format that one as well. You can now see the pricing is 200 and 311 euros. And I can do comparison to the one before where it was 400 and 650 euros. So I can tell my customer, my partner, my boss, whoever is asking me, that's the pricing difference. If we go from E4 to E2, that's the difference that it will make. And this allows me to tinker with the different configurations, get the data, bring them into Excel, and then I can talk to people and just try things out. What happens if I make changes and so on. Okay, remembering that this is a lightning talk, I think I still am in time. Yes. So thanks a lot for listening. I hope it gave you an idea. Again, more details can be found on my blog, or if you just want, feel free to contact me directly. And now I'd be happy to have any questions if anything came in.
Hey, thank you very much. These were really tangible demos and issues you've addressed. So thank you very much. One question, do you use development containers in other contexts as well?
Yeah, absolutely. Whenever possible, when it's possible to Linux for me, I'm using dev containers because it's a very stable, very useful feature. I like it a lot. It helps me to have separated, clean environments. And yeah, I'm really a big fan of them.
Okay, fan of containers. And
absolutely.
The second one would be, how do you find the right filter when calling the pricing API?
Yeah, that can be slightly tricky. What you can do is that you get all the data and then you can do a search, basically a text search for something that sounds like this. And you can also filter using wildcards. So you don't need to have the exact name. You can also do wildcards and contain search and so on. So you can kind of limit those answers down to find the right one. But that indeed can be a tricky part of it.
I think all of the cost efficiency is the tricky part.
Yeah, it can be, absolutely.
Thank you very much. If you want to give one more advice to developers and decision makers and IT pro for cost efficiency in Azure, what would it be?
Always give it a try. So far, I've been quite experienced with cost calculation, but if you run it for, let's say, a day or a week, then you will always find differences to what you calculated in advance because you forgot a part or whatever. So don't trust your theory, try it out in practice, and then you can take it from there.
That's a wise advice. Well, thank you very much, Tobias, for being with us today.
Thanks for having me.
I hope the weather continues to be nice.
Absolutely. I'll do some watching now, but then I'll go outside.
Yeah, thank you very much.
Thanks for having me.
If I had to pick one feature of app service, I think it would have to be deployment slots as my favorite feature. Deployment slots allow our customers, or any user of app service, to have what I call zero downtime deployment. Historically, when you deploy your application to a web server, at some point you have to put up a web page saying, "We'll be right back, don't worry, the site's not gone, but we're updating it." And when you update it, you copy the files to the server. Problem is, you don't know if those files have actually landed correctly or not until you take that page down and open it up to the world. At which point, if something bad happened, the entire world is there to see it, and you have to put the page back and try to troubleshoot without being able to see it. Deployment slots, however, give you an invisible version of your site behind your production slot. You can deploy there to your heart's content while your customers continue to use the production site. However, you can access that hidden or staging slot of your website. So you can go and make sure everything landed correctly, you can do any smoke tests that you might want to do, and when you're ready to share it with the world, you simply swap the slots and everyone sees the new value with zero downtime. Let's say something still goes wrong. Traffic starts to come on really heavily, you have a performance issue, all you have to do is swap them back, and then what used to be production is now back there again and you're ready to rock and roll. So deployment slots, zero downtime deployment, it's an amazing feature of app service. Getting started with Docker when using Azure is amazing because we have so many different ways to get you introduced to it and then grow you all the way up into something like Kubernetes. To get started, you can use Azure App Service, which is an amazingly easy service to stand up, and there you just point it at an image you want to run, we'll download the image for you and host it inside of App Service. Using App Service, you get to take advantage of all the cool features, for example, deployment slots, instant scaling it up and scaling it out, and you've been able to do that by just learning a little bit about Docker. If you wanted to spin up your own Docker cluster, you could do that yourself using all of our VMs, or you could use something like AKS. AKS is our Azure Kubernetes service that allows you to now have a fully orchestrated environment where you can run all the workloads with containers that you want to. So no matter if you're just dipping your toe in it and you want to start with App Service, you can. If you're ready to use things like Kubernetes, we're ready for that as well. So wherever you are on your container journey, we're here at Microsoft to help. learn more about Azure, or actually anything Microsoft, just go to docs.com. That's going to take you to a landing page where we can get documentation on everything inside of the Microsoft ecosystem, specifically Azure as well. So there you can drill in and learn about all the different services that we have, the resources that we have, how to spin them up. We'll give you architectural diagrams. We'll give you quick starts. Within 5 minutes, you can have new resources actually spun up in Azure that you can start to use. I find that Docs is amazing because it's also open source. So if you find something that's missing or an error, you can go to our GitHub repository, fork the repository, and send us a pull request, and you can see your changes live in Docs. We've also localized Docs. It's an enormous number of languages that you can use, so no matter what language you speak, you're going to be able to have a really great first-class experience in Docs. So no matter what it is that you want to learn about at Microsoft, just go to docs.com, and you're going to be met with all the value and information that you can possibly want.
Hey, it's still Alexia. We're still on the VACD 4, and it's 4:20 in France. So welcome back, everyone. I'd like to introduce you Alpa, who's going to talk about sentiment analysis using data and cognitive services. So hi, Alpa. Welcome.
Hello, thank you.
How are you?
Yeah, I'm doing good. Thank you. And how are you?
We're real fine. I'm really glad you'll be there. So thank you for being here. And I'll let you maybe just to introduce your subject. I heard that you're going to talk about a lot of Azure services. So maybe what is, according to you, the Azure services that is the most interesting for you if you only had to choose one?
Yeah, Azure Data Factory.
Azure Data Factory. Okay, well, we'll see why. And thank you very much, Alpa. And
Thank you.
see you.
Yeah. Shall I start? Hello? Shall I start now? Hello?
Yes, Alpha, you're live. You can go.
Yeah, okay. It's okay. Thank you all and welcome to my session, a case study, sentiment analysis using Azure Data Factory and Azure Cognitive Service here at Azure Community Day. Purpose of this session is to provide you a quick overview of Azure Data Factory and show you how you can do a sentiment analysis in your Azure Data Factory without any prior knowledge of data science, machine learning, maths, or other programming languages like Scala, Python, or Java. So please stay tuned with me. Myself, I'm Alpa Budpati and I'm working as Azure consultant at Cluster Reply. I have also provided here my LinkedIn information. So if you would like to contact me or if you have any question later on, then please feel free to contact me. So let's start with today's agenda. So in first part, I'm going to provide you an overview of Azure Data Factory, which is very quick. Then we're going to see case study and then we conclude this session and we move into Q&A. So let's start with Azure Data Factory. So what is Azure Data Factory? Azure Data Factory is a cloud-based data integration service that help you to do orchestrates, automates the movement and transformation of your data at a scale. Also, it is a platform as a service, so you don't need to worry about infrastructures. And because of that, it's a serverless, so you don't need to worry about hardwares or infrastructure at all. And because of these two reasons, it is a only charge you when you consume things. For example, if your Azure Data Factory is execute, during that time it will generate a charge. Otherwise, there is no any execution cost. You only pay storage cost, which is very, very small and it's a negligible. So it's a cost effective. Also, it is a no code or low code solution. So using UI, you can build your workflow pipelines very quickly and very efficiently without writing any code or without knowing the knowledge of other programming language. So let's start with key components. So in Azure Data Factory, we have a mainly 5 key components. So let's start with first one, which is linked services. Linked services are it's like a connection manager in other programming language or database language, which hold the connection strings and who authorize your data source. So here, linked service hold the connection string of your data source. So it can use by other key components in Azure Data Factory, such as dataset and activity and in a pipeline. So that is a link services. And in Azure Data Factory, we have around 90 to 90 link services available. So you can hold the connection string of the 90 different data sources. So let's move into next one, which is a datasets. Datasets is nothing but is metadata about your data. So it's whole the structure of your data. So for example, if your link service is holding the connection string of your data source, for example, Azure SQL Server, then your dataset is in form of table. But if your link service is holding the connection string of a REST API data source, then your data sets in a form of the JSON. So it's hold the JSON data. So that is a data sets. Let's move into third one, which is activities. Activities is nothing but it's just a specific task. For example, copy activity perform a copy task from one data source to another data source. From Databricks activity, perform the analytical tasks in your Azure Data Factory. For machine learning activity, do a machine learning task or execute a machine learning algorithms or module in your Azure Data Factory. So these are the activities. And in Azure Data Factory, we have a lot of activities available, which we can see during the demo. Let's move into fourth one, which is a pipelines. Pipelines are a logical group of your activities and who do a specific requirements for your business outcomes. So once you have a pipeline is ready, we can trigger it, and we can trigger it in various different way. We can trigger by time, we can trigger by when file created or deleted from blob storage, and we can do via custom activities. So these are the 5 main important key components of Azure Data Factory. Let's move into what can you do in Azure Data Factory. So as we have seen earlier, there are 5 main components in Azure Data Factory. So when we create them via UI by just dragging and dropping, behind the scene, Azure Data Factory will generate a JSON code. So you don't need to worry about JSON code because it's automatically generated for you. And that one is ready for your source control. Also, it provides built-in Git integration. So you can do it in two different ways. You either use Azure DevOps Git or you use a GitHub. You also can monitor your Azure Data Factory components, and you can manage your Azure Data Factory components using the UI. So let's now move into next topic, which is a case study. So in this case study, we are going to see a sentiment analysis using the Azure Data Factory and cognitive service, which is tax analytics. So we had a client earlier, and it's in a retail domain, and they would like to do a sentiment analysis on their customer feedback data source. They would like to do them as soon as is possible because of some seasonal reasons, and they would like to do it without hiring any data science expert. And they like to do it in manner like no code or no code in an existing solution, because they have existing solution is Azure Data Factory. So we got to know that we can do it via cognitive service. We can call the REST API as a text analytics service, and we can do a sentiment analysis in Azure Data Factory. So let's see here. These are the points. It's a problem statement which we have just seen. So these are the higher level design. So for that, we have created a blob storage which hold the source files or source data source. And in client scenario, we had a various different data source, like it's a CSV file, it's in a text format, it's in a JSON, and it's in a other tables form as well. But here I have only considered the CSV file for this demo. So this CSV file has a customer feedback, and it's about to a particular products or service. Customer has gave a rating and feedbacks. So that we have stored in a blob storage. So for that, I have created Azure Blob Storage Service resource, and inside I have created a container which is a feedback dash in container, and this container holds the CSV files and it's a feedbacks from a customer. Then I have created sync data source, which is a Azure SQL Server, and this sync source hold data in form of table. Then I have created Azure Key Vault services, which store these two source connection string in a Azure Key Vault, which is in a central place, and it's a very secure manner. So it's very good practice to use Azure Key Vaults. Then I have created a Azure Cognitive Service, which is a text analytics, who do a sentiment analysis without any prior knowledge of data science or machine learning or maths. And then I have created my Azure Data Factory resources, and I have created pipelines, and I have created data flows here. So basically, first step is to Azure Data Factory pipelines reads a blob storage file, and it applies the cognitive service in REST API call, in web activity call, and then it stored the result into a Azure SQL Server database with a sentiment analysis. So this is the high level design. So let's now move into Azure portal demo. So here you can see that let's go to homepage, and here you can this is my resource group who hold the resources for this demo. So I have a Azure Data Factory, Key Vaults, Logic Apps, Azure SQL Server, and storage account. And I have a text analytics, sentiment analysis service as well. So let's start with first Key Vaults. So this is my, where is gone? Okay, let's go to here. So this is my Key Vaults, and you can see that Key Vaults hold the secrets. As I have 2 different data sources, so these key vaults hold the 2 different data sources connection strings. So I have blob connection strings and I have a Azure SQL connection strings. So once I store the connection string here, then after I need to do one important things, and that is the access policy. So here I have to add a access policy for my Azure Data Factory, and I'm giving permission for a secrets. So if I do that this thing, then and then my Azure Data Factory can access the secrets. Otherwise, there is no chance, and it gives some errors. So this is the very important things that we should give a. We must give the access policy for Azure Data Factory. Otherwise, it will fail. So that is the key vaults. Let's move into blob storage. So this is my blob storage, and here I have a feedback desk in container, and here you can see that I have a customer feedbacks, and my customer feedbacks is look like this. So this is very simple data. Because of this demo, I want to run it very quickly. So here you can see that I have customer ID, I have product or service name, and then I have a customer feedbacks here. These are my customer feedbacks. So they say dislike it, or they don't like it, or they are very frustrated, or those kind of things. So let's close this one. So that is my source file. And let's now move into my sink, which is a SQL. So here at the moment, I don't have any data. I think I let me delete it if they have any data. So this is my destination or sink. So let's start one, and let's see now here. We're moving into Azure Data Factory pipeline. So here you can see that this is my Azure Data Factory pipeline, and here I have a lookup activity which hold the source and which find out the source from container, and it passed to a for each loop. So if you see it here as well, then you can see that you can see that this is my lookup feedback records. And let's see here. So here you can see that it has a total 8 records. As I showed in my source blob container, it has 8 records. And these are the information, that customer ID, product name, and feedback. So there are total 8 records as a source and as an input of a for each loop. And for each loop will run for 8 times because I have 8 records in my source file. And here I have used a sentiment analysis. I have used a web call here, and then I have set here my sentiment analysis URL, and I use as a post method, and I have used this required information, and this is actually your sentiment analysis ID. And you can see that I'm passing now here required information. So I'm saying that language is in English. You can change here different language as well. And here I'm passing my customer ID because I really need it for my data flow task. And here is a result of, here I'm passing the input like product one, and like feedback is product is not good. So that feedback is goes to here. So that is the body part of sentiment analysis. And then I have used the append variable here. So once sentiment analysis result comes, I'm storing into append variables. So here this execution will do for total 8 times, or it will work for how many items I have in my source file. So at the moment I have 8 items, so this will for each loop work for 8 times, and then it will do one by one record, and then it pass to append variable, and append variable store into one results. So that is my for each loop. So once I have this finished, then result of this my for each loop activity will store into blob storage. So here I have used a blob storage call, and it's REST API call, and it store the result of that append variable into a Azure blob storage. And then I'm using that one in my mapping data flow, and then I'm sending the email here. This is a mapping data flow, and then you can see that here that this is my blob storage URL. It's feedback dash staging, so it's storing into different container. And here I'm appending and I'm concatenating my source file name with a timestamp, and I'm giving in a JSON name. I want in a JSON format. So that's the different thing. That's using with a concatenation. So, and then here I'm passing my append variables as a body to store the file into a blob storage in one time rather than each and every time. So that is storing into blob storage. And then my mapping data flow will do some transformation and do some join, and then I would like to store into Azure SQL Server, which this mapping data will do. And once my pipeline is run successfully, I would like to send an email because I would like to operationalize my pipeline or workflow. So this will send the email to a particular customer, or like for me example, because at the moment I store my email ID. So here you can see that this is the URL of Logic Apps, which I will show you after some time. And here I'm passing the required information like my pipeline name and data factory name, because we have a different data factory name in different environments. So I'm passing my data factory name, pipeline name, runtime ID, and if there is error, then error message and time. But here I can pass as many parameter I would like to send. So that is my uh, body of this sending email. And I'm doing in two way. If it's success or fail, both way. If it's fail, then I'm sending a error message. So here you can see that I'm passing the error message from previous activity. So that is one. And I'm calling logic apps. So let me show you logic apps here. So this is my logic apps who sending the email. So like this is the information which I'm getting from Azure Data Factory. A message, data factory name, path, if I would like to attachment. So those are the parameters. And I am initializing here message body. And here I'm sending email. I have used just a Gmail at the moment, but generally in a live or a product environment or any customer scenario, we use either SMTP or SendGrid or Outlook methods. So this way, once my pipeline runs successful, you can see that I get email like this way, that my pipeline is this executed fail or success, and it give the message as well. So this one was previous one. So this is a logic app. So let's go back to here. And let me run it one more time because I have deleted here. And let me delete one more thing. Let me delete one more thing from my staging, because I haven't added earlier that delete when you start activities. So I have done that. And now let's run one more time pipelines. So let's run one more time. So while it's executing, let me show you mapping data flow. So I have a turn on my data flow here, but if you don't need it, you need to turn it off, because behind the scene it's run Azure Databricks Spark cluster. And if you make it turn on, then Azure Data Factory will charge you per hour. So try to turn it off if you don't need it. But it's a very good feature because you can review here your information. You can preview your data. At the moment, I think I have cleaned the file, so we don't see it. But let's see this one maybe. So here we can preview like what we have in our data source. or sync or wherever in output of join or output of group by or like that. We can view it here very, very quickly. So I think we just need to wait for execution of our pipelines. So let's wait, like while waiting that one, we can see it here, result as well. So as we have seen that for each loop will run for 8 times. And here it will do, for each loop has a two components. One is a sentiment analysis web call and append variable. And here you can say input and output of each record. So like see the ID, customer ID 6 and sentiment analysis positive. Like that you can see for all individual. And here you can see that final result. So we are writing this one into blob storage, and here you can see that this is my input. So here you can see that I have a total 8 customer, and I'm storing customer ID, and I'm storing sentiment analysis, negative or positive or neutral. So that is output of sentiment analysis, and I'm storing into blob storage. And then it will use by data flow, which is running at the moment. So while it's running that, let me show you sentiment analysis result in here. So let's refresh this. Yeah. So here this is output of a sentiment analysis and output of a append variable. And here you can see that it's storing in a JSON format. And you can see that it's storing as ID, which is a customer ID, and sentiment analysis like is positive, negative, or neutral. Yeah. So that is my sentiment analysis result. And now my mapping data flow will store into Azure SQL Server after doing some transformation. So let's see, still doing, let it do it. So meanwhile, I can show you something else. Like here I have used a set variable, which actually do date timestamp. So because every time when I run my pipeline, I want to give a file sync file name as a concatenation of timestamp. So that's why I have used this one, which concate a timestamp on a file name. So this one is a variable which store the timestamp, and then I'm using in a sync data source. So let's go to mapping data flow, I think. Yeah. So here you can see that this is my source file, and you can clearly see that what inside my source file without executing pipeline. So that is the one. And here is my feedbacks and products and customer ID. Then here I think we just need to wait if his file is not ready. So here is the result of sentiment analysis for each customer, for each record. And then here I'm joining these two data source because I need extra information. I need a product name from my source, and I need sentiment analysis from my result of sentiment analysis. So here you can see that customer ID, and here you can see that the sentiment analysis as well, that this sentence is negative, positive, or neutral. And here I'm just aggregating them because I want to see how many feedbacks are positive, how many feedbacks are negative, and how many are neutral. So that's why I have used aggregation, and I'm storing them into a blob storage, which I will show you after this transformation. And here I'm storing the result into Azure SQL database. And here I'm just giving not aggregation, but I'm giving product or service name and customer ID and feedback. So that's why I need to join my original source, and I need to join with sentiment analysis result. So this comes from in container. Here you can see that original file, and this comes from result of sentiment analysis, and this one is come from staging container, and this one is in JSON format, and this one is in container. So I'm using two different containers, and this one is CSV file, and this one is a JSON file. So you can see that you can join two different source, like one can be CSV and one can be JSON, and you can join them very easily and very quickly by just drag and drop. Everything in Azure Data Factory, you just need to search and you just need to drag and drop. Like for example, let me show you here. Let me show you in pipelines. Before that, let's move into here. So let's see here, if you want to add any components, then you can easily do that. So this is list of all activities. See how many different kind of activity available in Azure Data Factory, and you can just search here and you just do that. That is a simple, very simple. You just need to drag and drop, and you can very quickly build your pipeline, which is very effective and very time saving. So this is the one, and let's see if it's run successfully. Then we can visualize here, and then finally I will show you in a SQL Server as well. So this is aggregation, and this one is similar. If you are from Azure SQL or SQL background, then you can see that it's just a group by, which is we have in a SQL Server as well, group by syntax. You doing aggregation or group by. And here also you can easily add any components by just see here is available all components. You can do window, rank, you can flatten your complex JSON file into a data format, you can filter it, sort it, you can alter it. It's very quickly. You just need to select here, then it will automatically comes here. So that way is drag and drop, very simple. And so now let's see if it's finished execution. Then we can see yeah, it's finished, it's success, it's done, execution is done. And even you can see that my let's go to logic apps. If you see here, you will see that it has executed. No, not a coding one. This is design and this is overview. So here you can see that this has executed in a recently, 2 minutes ago. And you even can see it, what it went or how it went. So you can see that this is my source and coming from Azure Data Factory. And here you can see that message body, and here you can see that like parameters. So this way, and you can see that I get one message as well after some times. It take few minutes. Yeah, I get this message as well. So that's one. And let's see, is it stored result here? So you can see that my mapping data flow have inserted 8 rows here. And you can see that it's giving me like my customer ID, product name, and here is my feedback that I'm saying that this is a very good service. I really liked it. So it said it's positive. But if I say that it's a bad, very bad service and system is not working correctly, then it's giving negative. But if I say that like see here that 2008 SQL Server 2008 SSRS, most of the feature are deprecated, but it's still working. Here it said it's still working for me. So that's why it said it's neutral. So this way is give the sentiment analysis, and it's stored the result with a product name, customer ID, and sentiment result, and actual feedback as well. So it's storing into sync. And let's see one more thing in blob storage. Let's go to here, bake, my resource group, blob storage, and here you can see that this is my staging, which I already show you. Let's go to here, bake, and here you can say this is my final container, and we need to see today's time now. So it's this one, latest one. And here you can see that it's giving me aggregation, how many are positive, neutral, and negative. So it's storing into blob storage as well, and it's inserting into Azure SQL Server as well. And one more thing I want to show you, that one is here. preview. So after that, I think also while it's doing that, let me show you one more thing, that this is a monitor view and this is a manage view. So you can monitor as well here as well. You can monitor your each and every pipeline. You can see that it's success or fail, and you can see error message as well. And you can redirect into internal activities as well, internal activity, pipeline, data flow, like, and this Google icon will show you the in and out of your data flow, and it show you your lineage view as well, like which column from file or table are used for which activity or component. So that is, and you can see that this is my blob sync, and you can see here reset as well, and even you can see that here as well. So that is from demo, I think. We're just waiting for this, and then after we can conclude this session very soon. So let's wait for a few seconds. So while doing that, you can see that you can publish your pipelines. See, this is the result for which I have stored into Azure SQL Server. So if I want to see before storing it, then I just need to turn on my mapping data flow, and I can see it here, debug flow. So this is very, very powerful and good tools, and you can very quickly build your pipelines and workflow. So with that, I would like to go to slide, and with that, I would like to conclude this session. So initially, we have seen Azure Data Factory, which is a cloud-based data integration service, and it helps you to movement and transformation of your data, and it's a no code or low code solution. So you don't need to worry about any programming language, and you can build very, very quickly your workflow and pipeline. You can parameterize it, you can operationalize it. So that is Azure Data Factory. Next, we have seen key components of Azure Data Factory. There are five key components of Azure Data Factory. Then we have seen sentiment analysis in Azure Data Factory. So generally, we can use this technique in anywhere. Like you have a customer feedbacks or review from anywhere, from social media, from retail domain, or from any domain. Even you have like complex paragraphs or books, it can give you the sentiment of that page or paragraphs or anything, and it's give you the very identify the sentiments or identify the meaning in very good manner and very quickly. So that is a sentiment analysis, and you can use it in various different scenarios. So with that, I would like to thank you for attending this session, and thank you for listening me, and I would like to thank you for Azure Community Day teams for allowing me to present this session. And with that, I am now open with question.
Thank you very much, Alpa. Thank you. So we have a couple of questions for you.
Yeah.
First one is, are there different ways to trigger ADF pipelines?
Yeah, definitely. So you can trigger your pipeline in a various different way. You can do it via time. So you can schedule it based on time. Like you can schedule your pipeline based on a particular day, in a time, or end of the day, or start of the day. Or you can trigger your pipeline based on when file is created or deleted from your blob storage. You can trigger your pipeline by custom activities such as Azure Function, Logic Apps, PowerShell, or C# code. So yeah, you can do that. Yeah.
Okay, thank you. And the second question is, can we deploy ADF using Azure DevOps?
Yeah, definitely. You can deploy your Azure Data Factory in one environment to another environment in I think two different ways. First one you can do by manually. So you can do it by just import and export ARM templates. Let's see here. So you can download this AMP template, like export your AMP templates from a dev environment, and then you can import that AMP template in another environments. In another environment, you open your data factory and then you import it. So it will deploy it all pipelines and other components of your Azure Data Factory. And another way you can do it by just using the CI/CD pipeline. So for that, you have first of all need to set up your Git repository, and then you can use Azure DevOps to do a continuous integration and continuous delivery of your Azure Data Factory. Yeah.
Okay, so thank you very much, Alpa. Thank you for the talk. So as you know, we are live on YouTube. If there are any extra questions coming up, I encourage you to go check it out. And so thank you again. And now in a couple of minutes, we will welcome the next speaker, who is Ron Dagdag. And with Ron, we're going to speak about leveraging the power of machine learning with Onyx.
Thank you. Bye.
Thank you. Bye.
Hi, I'm Leslie Richardson from the Visual Studio team. In the past few months, we've released 3 preview versions of Visual Studio 2022 that give you the power to personalize and be more productive in your development environment. Now, I'm super excited to share with you some more awesome features that are now available for Visual Studio 2022 Preview 4, which has just been released, so let's go check it out. One cool new feature that we introduced back in earlier previews of Visual Studio 2022 is Hot Reload. And in Preview 4, now we've added Hot Reload support for Razor files. So now if you're making changes to your C# code in a Razor file and you hit save, all your changes will automatically take effect in your ASP.NET application without having to manually recompile. We've also added hot reload support for CSS, and in this scenario, you don't even have to save your updates to immediately see them in action. Once you add your changes and the CSS file is syntactically correct, your program will automatically update with those changes whether you chose to save or not. In this example, I've got a basic HTML list of numbers that I want to convert to a grid format. So all I gotta do is paste in the related CSS and voila! My app is automatically updated with hot reload. Performance is always a top priority for Visual Studio, and Find in Files is one tool that we've improved performance for in Preview 4. So if you've got a huge project in Preview 4 that's got hundreds of files or even thousands of files that you'd like to search through using the Find in Files tool, you can see results up to 3 times faster than in previous versions of Visual Studio 2022. All right, so as a Visual Studio Debugger fan, I am very excited about the highly requested addition of dependent breakpoints that are now available for Preview 4. Dependent breakpoints let you enable a specific breakpoint only after another breakpoint is hit. So if you've got a section of your code, such as a game loop maybe, where you'd like to enable a particular breakpoint but only under a specific circumstance, but are unable to use a conditional breakpoint because you want to trigger the hit from either another page or a controller or something like that, dependent breakpoints are definitely the way to go. Now this last feature is for all the C++ developers out there. One of our goals for Visual Studio 2022 is to make it easier for C++ devs like you to build, test, and debug your cross-platform supported programs. Specifically, Preview 4 now makes it easy for you to target the Windows subsystem for Linux, or WSL2, by using the F5 dropdown, where I can select WSL Debian, for example. From there, I can run my program that will print out an ASCII cow, And the output is moved, sorry, from Linux to Visual Studio, as you can see here. So as you can see, there are a lot of really neat additions to Preview 4 of Visual Studio 2022, and that's not even the half of it. So if you haven't already, be sure to download Visual Studio 2022, try it out, share your feedback, and happy coding.
If I had to pick one feature of App Service, I think it would have to be deployment slots as my favorite feature. Deployment slots allow our customers, or any user of App Service, to have what I call zero downtime deployment. Historically, when you deploy your application to a web server, at some point you have to put up a web page saying, "We'll be right back, don't worry, the site's not gone, but we're updating it." And when you update it, you copy the files to the server. Problem is, you don't know if those files have actually landed correctly or not until you take that page down and open it up to the world. At which point, if something bad happened, the entire world is there to see it, and you have to put the page back and try to troubleshoot without being able to see it. Deployment slots, however, give you an invisible version of your site behind your production slot. You can deploy there to your heart's content while your customers continue to use the production site. However, you can access that hidden or staging slot of your website. So you can go and make sure everything landed correctly, you can do any smoke tests that you might want to do, and when you're ready to share it with the world, you simply swap the slots and everyone sees the new value with zero downtime. Let's say something still goes wrong. Traffic starts to come on really heavily, you have a performance issue, all you have to do is swap them back, and then what used to be production is now back there again and you're ready to rock and roll. So deployment slots, zero downtime deployment, it's an amazing feature of App Service.
Hello, and we are back for the last talk of the Virtual Azure Community Day. I hope you are enjoying it so far. And our last speaker for today is Ron Dagdag. So hello, Ron, how are you?
I'm doing good. How are you?
Yeah, very good. Very happy to meet you and very excited to hear about your talk. And so just the topic of the talk is how to leverage the power of machine learning with Onyx. And before that, I have a question for you, Ron. So I read in your bio that you're studying the convergence of augmented reality, virtual reality, machine learning, and the IoT. So what does that mean? What is this convergence exactly?
So the way I kind of see it is that more and more, a lot of our devices won't feel like devices. It's going to be embedded into like walls or embedded into something that we use every day. And that convergence between the augmented reality and making of the Internet of Things, all that is possible because of machine learning and and AI. And a lot of these, you know, become seamless and more of something that helps humans, right? It's more of an augmented intelligence. So you think about the stuff that you use every day. You have your phone. What if you don't have that phone? That is just the information gets to you where you need it at the time you need it, and that information, the sensors that gets collected and all that data can be accessed and be able to uh, to uh, to to be able to use as needed. Does that make sense? And you'll see it more and more, right? All your smart devices that is going around you, right? All that is possible because of the power of machine learning and AI.
Okay. Thank you very much for this explanation. I'm sure there's a lot more to say about it, but it's a really nice first thing to hear. And now let's dive into more machine learning. We are all ready for your talk, and so when you're ready, let's go.
Cool. I'm ready. Good morning, good afternoon, good evening, everyone, wherever you are in our virtual world. My name is Ron Dagdag. Today, I will be talking about leveraging the power of machine learning with Onyx, and we'll define what Onyx is. But we're ready to go. Onyx, we're going to talk about not these Onyx. If you're a Pokemon fan, I'm sorry, we're not going to be talking about Pokemon today. And not, of course, if you're a scientist or a geological scientist, we're not going to be talking about the stone onyx. We're going to be talking about onyx, ONNX. So let's take a step back. What programming really means, right? When you're tasked into something that you want to create, like a program, you need two things, right? You need the input and the algorithm. And as a developer, you would create and generate that algorithm, and of course, you send it to a computer, and it will give you the answers. On the machine learning side, it's like the other way around, right? You have your input, and then you feed answers and show examples to the computer. The goal is to teach the computer to generate an algorithm for you. So as a machine learning primer, programming, we already know we need input, algorithm, and it would spit out answers for us. In machine learning world, we have answers and input, and we feed it to the computer so that it will generate an algorithm for us. So machine learning world, we call that training data, and you use a training framework in order to generate a model, and that model you would use into your application, and now you'll be able to have an inferencing pipeline, right? And you need an inferencing runtime in order to use that model. And then, of course, now that you have the answers and you can feed the new answers into your as a feedback loop, and then you'll have some more training data later on. All right. So, what is Onyx? Typically, here's a problem. You have data scientists. Some data scientists knows a lot about PyTorch, and so they would program it in PyTorch locally on their machine, right? And then, of course, I found out researching a little bit more, there's different skill set. If you're a JavaScript developer, you already know all these different JavaScript frameworks and how all these different new framework that's coming out in the JavaScript world. It's kind of like the same way in in the AI world, the machine learning world. There's all these different machine learning frameworks that you can use or that to program. So it depends on what the need, what the expertise of the data scientist or that developer that would have that data. And of course, not just that. Once you have the model and you want to deploy it, it does not just run on the computer, right? You also want to deploy it into a cell phone or you deploy it to the cloud. All these different target places where you can deploy them. Sometimes you want to run it not just in the CPU, you want to run it fast, and so now you need the GPU or some specific implementation of that device so that it'll execute faster. And then that's what Onyx is. Onyx is Open Neural Network Exchange. It is open source on GitHub. If you go to onyx.ai, that's a good place to learn more about this. But it's an open format for machine learning model. Think about this as the way I kind of see it is more of like kind of like a PDF, right? PDFs, you can, you maybe you created your document in Microsoft Word and then you convert it to PDF. So now it doesn't matter how it can get viewed. You can have, different viewers and how you open the PDF, but it's a format that you can use to view a document. The same way as neural networks exchange, you'll be able to program it in one language, or do your training in one language and then be able to deploy it to different output. Every time I would look at the Onyx AI, the ecosystem have grown. It actually got started with partnership with Facebook and Microsoft. Maybe I don't remember the time now, 4 or 5 years ago, but now all this ecosystem have grown and all these different partners have contributed to the open source project. It has about 11,000 GitHub stars, about 2,000 pull requests, 200 plus contributors. It has about 2,000 GitHub forks and about 40 plus model that is available out there that you can just use. So existing ones that are available, you can reuse these Onyx models. So what I'm trying to get at is it is a Linux Foundation AI graduate project. It's becoming more stable. There's a lot of contributors, so it's a that kind of gives us an idea in terms of this open source project and how good it is and how we can integrate it with our application. There's a lot of tutorials out there how you would use it, but today our agenda is what is Onyx, right? When should we use Onyx? And then we'll talk about how to create an Onyx model, and then I'll show you how to deploy Onyx model or integrate Onyx model to your application. All right, so when do we use Onyx? We did talk about what Onyx is already, but now let's talk a little bit more about when should you use Onyx. When you have something that is maybe trained in Python, but now you want to integrate it to your C# or a Java or a JavaScript application, Onyx is a way to do that. When you have a high inference latency for production use, meaning you want it really fast. So let's say you're processing videos and you want it to make it fast and integrate it with your application, your C# application, that would be a good use that you want to convert your model into Onyx. Another one is if you have something that is a different resource, right? Like an IoT or an edge device, that would be a good use case to run, especially if it's on a constraint hardware. Another way is if you're running it on a different OS. So let's say you're a Python developer and you're using it on Windows, and now you want to run it on Linux or a Mac, or you want to deploy it to Android. It might make sense to convert it to Onyx first and then be able to use it for different hardware. When you're trying to also combine models that are created from different frameworks, so you can pipe them together, right? So one model, it would give you an output, and then that would feed to another model, and those kind of things that can kind of simplify. So you only have one, flow as data flows into your system. There's also something new where sometimes training takes too long, and when you want to use transformer models, Onyx allows you to be able to train and do fine tuning to your application to your models too. So we'll talk about how to create, with all these different frameworks and be able to do converters, or sometimes you can also use Azure Custom Vision to do that. And then on the deployment side, you can deploy it on a Windows device, IoT edge device, or cloud services in different ways how you would deploy them. So let's focus on step one. Let's create an Onyx model. How do we create one? Before I do that, data scientists, have you ever, baked a cake? And baking a cake, it it takes like different ingredients and all that. What I'm trying to say here is that your data scientists are kind of like your chefs. They actually create the secret recipe of your company. And secret recipe is pretty much the AI or the machine learning model that would improve the application, right? So they're the ones who's trying to figure out different ingredients, different techniques to be able to give you the recipe for the cake. So 4 ways and how you can create the recipe or the Onyx model, what I'm talking about here, right? You can have an Onyx model zoo, which is available at, on GitHub, meaning pre-existing research, like for example YOLO, or all these different models that is available out there that is from research. You can actually use it and integrate it with your application. Just download it. It's already pre-converted to Onyx. You can also use Azure Custom Vision to be able to generate an Onyx model for you. You can actually also convert existing models and then also train from scratch using Azure Machine Learning or automated machine learning there. Onyx model, MobileNet, ResNet, SqueezeNet, all these different models for image classification. It's already there. It's converted, and it gives you the different version how you would use it. Azure Custom Vision is more, if you go to customvision.ai, where you can upload your devices. Once you upload your images, once you uploaded your images, you can tag them. Like in this case, I uploaded images of fruit, and then I tag them as fruit, and then I can say train, and once it finished training, I can download an Onyx model and ready to go, and I can integrate that to my existing application. Of course, converting might be with all these different frameworks. So 3 steps in order to convert a model: load the existing model, convert it to Onyx, and save to an Onyx model. So here's an example of what does the Onyx model look like. At the end of the day, it's a list of graph of operations. So it looks something like this. When you can visualize it, there's an app. If you go to this Netron.app, you can upload an Onyx model there, and it would just show you a visualization of that application. It also helps as a developer, so I come in from a software engineering background. It helps me how to use that model. It tells me what's the input and what's the output of that model, and of course, how complex that model is, and it kind of shows the pipeline. So how do you convert an Onyx model? It looks something like this in PyTorch, where you have your import. You load the model. Once you load the model, you give it some sample input, and so some of the parameters, how to use that model, and then you would export it to an Onyx model. So that is one way. Of course, there's if you want to use Keras, and I'm not going to go detail on each one of these, you can also convert to TensorFlow, and not just you can use command line to do this. So there is a TensorFlow converter to Onyx. You can also use scikit-learn to be able to convert it to Onyx. You can also use Onyx as intermediary format, meaning if I want to use it on Android, I can, if there's something that I wrote in PyTorch, and then I can convert it to TensorFlow, and then from PyTorch I can convert it to Onyx. Then Onyx I can convert it to TensorFlow, so I can use it on my Android device. You can use Onyx also to convert it to Core ML so that I can integrate it to iOS. You can also do fine tuning, meaning if I want to improve the model, I can do that and create another model, another Onyx model on top of an Onyx model, if that makes sense. So there's a lot of tutorials out there. I'm just giving you some different links and different information what you can do with this. You can also train model in Azure Machine Learning, where you can train it locally, and then once you need to scale it with GPU in the cloud, you can use that. You can automate machine learning or hyperparameter tuning. At the end of the day, what I'm trying to say here is that typically you would build the model, but after you train and test the model, have a place where you can register and manage the model, kind of like you have your Docker hub, right, or your container instance, or not container instance, but where you store your Docker models or Docker images. So same way as your Onyx model can be stored into a registry somewhere, and then you can build that image and deploy it and do orchestration around that. So now that we talk about how to create a model, right? We know we can convert, we can download from the Model Zoo, we can use Azure Custom Vision and all those different steps. Now we will talk about how to deploy that and have that incorporated to your application. So remember, I did talk about baking a cake and the secret recipe. As a data scientist creates the secret recipe of your company. What's the difference between a baker versus starting a bakery? Real difference, right? Different skill set. A baker, just like your data scientist, they create that secret recipe. They create the bread. But as I come in from a software engineering background, or sometimes the infrastructure or creating the application, right? So starting a bakery is kind of like on the software engineering side is our expertise is knowing where to put the cash register, how to display it properly, how to create the pipeline, and how does the restaurant flows, right? How does the whole thing kind of overall, how does the experience works, right? As a customer, that is very important to know how to collect the payment, how to improve that system and make sure that that cake gets sold. So that's, for me, that is the important part of both having a secret recipe and and having a good baker, but also being able to have a good flow or have a good bakery. So that makes sense. So, and of course, every time you do that, you have to figure out, especially if we're going to deploy an application or integrate a machine learning model to our applications, we have to know, are we deploying in the cloud or at the edge? And I'll talk a little bit more of what the cloud edge is. If you think about McDonald's versus Subway here in the McDonald's, they have their bread shipped from bread factory, or some where they bake the cake. It's not at the store. Subway, they bake it at the edge, meaning at the store itself. So there's a difference right there, and it depends on what you're trying to do and what your goal is. That would determine when to use that analogy, or when to use the cloud or the edge. So deploying it with machine learning, deploying it to the cloud, you can use Azure Machine Learning to do that as a web service, or to capture model telemetry data. So this is that part right here where I can build an image and then be able to deploy it as a service if you want it in the cloud. So like a web service or something like that we can call. This way you can also use Onyx. There's actually Onyx Docker images where we can download them and start working with, let's say we want to just do conversion, or we wanted to do to incorporate it as part of our workflow, and be able to create a Docker container and then service models that way. So it's a good starting point. So if we want to deploy in the cloud, we can incorporate it in the Docker container, or we can incorporate it. And I'll show you a little bit of examples on how to do that. At the edge, of course, when we talk about the edge, it's all about these different devices, different container or different edge devices. How does it flow through and collect? Like, for example, if you want to deploy it on a Raspberry Pi, or if you want to deploy it on the phone, those kind of things. So edge means how close it is to the user. And of course, in terms of deployment, now we're thinking about, on the cloud, about 1,000 servers out there. Fog means it could be a gateway, or what we call the MEC, which is the mobile manage and edge computing unit. Meaning, if you think about 5G, that's what makes 5G work, is in terms of where does the computing happens, right? It's as close to the users are, or close to the devices are. In that way, it makes it faster to run and to process your data. So fog, you might be talking about millions of devices, but of course, edge devices is a lot more. And we're talking about billions of devices at that point in terms of deployment. I'm not going to, well, this one kind of talks about the different, types of edge, right? Where it is at in terms of smart edges, constraint devices, where they at. All these, you can deploy Onyx models related to this. It could be in the cloud, it could be on the regional edge, or at the fog level. On this one is the user edge, meaning on the phone, or maybe in the constraint edge devices, or the on-prem data center edge, right? So different ways in how you would deploy them. So why would you do that? Why would you have AI at the edge? Low latency is important. And then, of course, low latency, meaning if you're processing, imagine if you're processing a video feed, right? You need to be able to do, especially the computer vision side of it, and being able, let's say you're doing object detection. So you want it to be able to process the frames really fast. So you really need to be able to get the results faster. So instead of uploading those images in the cloud, getting results and getting results that way, you need to process it at the edge. You need to process that video feed as closer to the user, or as closer to the camera, so that it would have a better it would have low latency. Another one is scalability. Imagine if you have a video feed that you're trying to do inferencing, or you're trying to do object detection. You don't want to send that up to the cloud every time. You want to, because that would be expensive, right? You're uploading and you have your ingestion cost and those kind of things. It might make sense to just run it on an edge device, because it's cheaper. You have a machine out there, especially if it's capable of processing that data, to be able to it's cost less to run that. And of course, flexibility. There's some areas where you cannot send data outside of a factory, or data you can't send data outside of a specific locations, especially if we're talking about GPDR or GDPR, right? GDPR allows you to be able to process it locally rather than process it remotely. So that and of course, a good example there is when you're riding a plane and you don't have internet connection, or slow internet connection. your app still works because it still can process these data. So that's why it might make sense to have your AI at the edge. So Onyx Runtime is another open source application that is started by Microsoft. It actually is a high performance inference engine for Onyx model. It is MIT licensed. You can it fully supports not just Onyx, not just neural networks. Onyx also has even the traditional machine learning. That's what we call Onyx ML spec. It also has extensible architecture for hardware accelerators. So if you want to use GPU, if you want to use a different VPU or a different hardware, it abstract that one, and you can. It actually ships with Windows 11, not just Windows 10. Also, it has a WinML. You can go to onyxruntime.ai, and it's a place where, let's say you have your platform, or doing Linux as a platform, or we have a C# application, and the architecture is x86, and we want to use CUDA, and it gives us how to incorporate that to our application. Cool. So you might want to check it out. Depending on the project, what you're trying to do, it gives you instructions how to incorporate Onyx Runtime. Onyx Runtime is a different open source on GitHub. Onyx Runtime just allows you to be able to do to process Onyx models for inferencing. There's also Onyx Runtime Web, where you have a JavaScript library that you can run Onyx models on the browsers or in Node. It actually uses WebAssembly and WebGL technologies that it can just automatically knows, if CPU is available, it would use CPU. If a GPU is available, we just use the GPU. And I will give an example on that and kind of show you a little bit more about how to use that in a few minutes. Compatibility chart. So meaning if you're using Windows 10 or Windows 11, it actually works on Chrome, Edge, Safari, Electron, and Node. If you're using Mac OS, it's compatible with all that. Ubuntu, you can use Chrome, Edge, Node on that too, and then Android and all that. So this kind of gives you this Onyx Runtime Web, that it can be used in a lot of different applications, especially if you're doing Node and also on the browser itself. Okay. On the Windows AI, the Windows AI platform allows you to be able to have WinML. It's actually sitting on top of Onyx Runtime. It allows us to be able to do, if you have a Windows Forms application, you can actually integrate Onyx models to it. So it allows us to be able to use Onyx in some of the Windows applications, especially on desktop. DirectML, of course, is sitting. Onyx Runtime uses DirectML. So if you're creating games, DirectML is a good way to use. And of course, it's also an abstraction on the compute driver model. So where you have a GPU, a VPU, or however XPU that hasn't been thought out yet, that would use for processing. And of course, if you have CPU, Onyx Runtime directly uses that too. So I'm going to do a demo. Sometimes it might make sense to kind of work through and kind of see how it feels like and how to convert to Onyx model and how to use an Onyx model. So in this one right here, I am using Visual Studio, and I'm using Python Notebook and .NET Interactive to be able to kind of demo the a C# application that is running on these on a Python Notebook. So here's my data right here. I have a CSV file that has two things in it, two columns: years of experience and then salary. It's just a contrived application. We just want an input and an output at the end of the day, right? So what we're going to do is we're going to train our machine learning model. If it has this input, it would kind of guess, right, and do inferencing on the salary side, right? So first things first, we get the NuGet packages. The latest version of Microsoft ML is 1.6, and we're using this Onyx transformer and Onyx converter to be able to convert it to an Onyx model. So I already did that here. I'm downloading these NuGet packages. Let me see if I can start this. So once I download the NuGet package, I can now start using it on my application. So in this case, I'm using this Plotly and data analysis. This one right here is just allows me to be able to display it properly, what the CSV file is. And this is, by the way, this is on my GitHub account. So meaning the source code, so you can actually try it out and read it also for reference later on. So we're using this data frame to be able to load the CSV file. And then once we have the CSV file looks like this, where you have your years and experience and then salary. And we want to describe what that data looks like right here. You have your min, max, and then kind of gives you an idea of the mean. This one right here is just to shuffle the data. So I'm going to use it to train a model in ML.NET. So I'm going to start using it here, where I have Microsoft.ml to create an instance of the ML context. That ML context I would use to be able to read that the data frame and create a trainer. So in this case, I'm creating the pipeline. I'm specifying here, okay, use this trainer SDCA to be able to have this column salary, and then your output is the based from the years of experience as your input, and then output as your salary right here. And of course, there's always that pattern. It's always fit and then transform. So fit creates you a transformer, and then based from that transformer, I can pass in the test data to get the results. So data train right here is, when I split the data, my training data into and shuffle it, I'm passing that in here. So let's see if I can show you what the data train looks like here. See if it'll work. First, show that. Let's see. Show. Okay, looks like that data frame I cannot show. But anyway, let me see if I can run this one right here in terms of training. And then I can create, at the end of the day, what we wanted to do is to be able to create a model for us. So once we have the model, I can convert it to an Onyx model. So in this case, the model already exists when I created it here, right? Model.transform. So once I have the transformer, it created the model for us, and then I can convert that into an Onyx model. So right here, what I'm doing is I'm opening this model.onyx and specifying, the model that I wanted to convert. I need two things. I need the data and the stream, right? Data is my data set that I pass in. Anyway, so let's see how it runs. And so after it runs, it generated this onyx.model, model.onyx. And if I go to and netron.app, it would look something like this. As a developer, it kind of helps me identify in terms of years experience, in terms of what is the input, right? Years experience is my input, and salary is one of the inputs. It tells me right here what is the output. So now, as a developer, I know what my input is and what is my expected output. The important part here is the score, dot output, and the score dot output would determine what my what the results of the inferencing for this. So let's go to another Python notebook, and this time my Python notebook here is a it is in Python instead of .NET. And what I want to show you here is how I would use it for my application. So there is a Onyx runtime. So I did pip install Onyx runtime. And then what this one does is it actually loads that Onyx model that I converted from C# from ML.NET, load it to this inference session. And once I have this inference session, I can read through what are the inputs. In this case, I'm going to run this. It gives me years of experience, what that shape looks like. Another one is the salary input. The salary input is going to be ignored, but for some reason, it requires us to be able to use that model. So that's the reason why I'm looking at, what are the data set that I have here. And then, of course, looking at the output. In this case, I'm only interested in the index 4, meaning the score output. And that would give me the type. And so in this case, if I want to use it, it tells me I need to be able to pass in, like in this case, 2.5 years is what I want to pass into my my application. And then I specify the salary is 0 because it's going to be stubbed. And if you look at the model itself, looking at this, I know it's not going to be used. It's only using this year's experience to be able to get this score, that output. The rest of them, it's not actually used because at the end of the day, that's the important part, is to know what is the expected output is. So this is the only input that I need anyway, but the rest of them, just to get it going, I need to pass in the salary information. So I pass in 0, I pass in here 2.5 years, and I will read whatever the output is. The rest of them, it just passes through, it looks like. Okay, so based from here, I'll able to run it, session.run. I pass in the output name. I would pass in a class that has the input experience, years, and then the salary. Once that get result, it will give me a value like this. It tells me the expected value, and I can plug that in, I get that value, and there you go. That is the result of my inferencing. So what I did show you today is I have an application that actually runs in C#. I converted it to an Onyx model. I have a Python application, and I want to use it and be able to read through and get the results of the inferencing that way. Cool. How are we on time? Just looking it up. We have a few minutes left. On this GitHub, on my GitHub application also, we have the node application, how you would use Onyx model. It's the same. In this case, I have a different Onyx model that I can use, and how I would pass in some data and be able to get results. But the pattern is about the same. You load the Onyx model to a session, and then you pass in the parameters for that session in order to get the results. And once you get the result, then you can pipe it to your to your then you can start using the result of that. All right, let me go back to my presentation. If you need a copy, or if you want to go to that GitHub link, you can use this QR code to be able to get to the link to the GitHub. Other than that, I think that's it for me. And this is how it feels like after learning more about the capabilities of what Onyx can do, right? All these different ways how you can create an Onyx model and how you would deploy an Onyx model. So just to recap, what is an Onyx model? It's an open standard that you can use the right tools for the right job, and be able to run it efficiently on whatever target platform. I did show you today how to create Onyx model. You can be converting it to an Onyx model, or you can, from PyTorch to an Onyx model, or TensorFlow to Onyx. You can download it using, you can create it using custom vision. You can also download an Onyx model from the Onyx Model Zoo. And I also showed you from the demo today how to deploy an Onyx model using Windows ML, using .NET and Python, and all the and also talk about Onyx runtime. Cool. All right. If you're interested in learning more about me, my name is Ron Dagdag. I'm a lead software engineer at Spacey. I'm a Microsoft MVP. If you're interested in learning more about my projects, go to dagdag.net. The best place to contact me is through LinkedIn, at Ron Dagdag on Twitter, on LinkedIn page. And I appreciate you geeking out with me about Onyx models and neural nets and all these different things. I appreciate your time and have a good day. Thank you. Any questions? I'm open for questions.
Thank you very much, Ron. Yeah, I have one question to start with. So if I wanted to get more information about Onyx, if I wanted to try it out, how could I do that? Where should I go?
The best, there's a lot of examples. You can go to onyx.ai to be able to kind of learn more about the Onyx project. There is, some of the samples I have here, I think it's a good way to start with. On GitHub, there's a lot of examples out there how to convert to Onyx. There's also, and I'm gonna post this one right here in case someone is interested in learning more about it. Also, there's Onyx runtime. If you go to Onyx runtime, just Google Onyx runtime, it'll give you to the main site, and it actually tells you right there step instructions and how to incorporate, depending on the application you're trying to do. Right. So if you have a web application, there's a Onyx runtime web. If you have a desktop application, there's also Windows ML you can look into. So there's a lot of examples out there and step-by-step instructions how you would do it using Onyx runtime.
Okay, great. So thank you very much for your presentation. It was a great way to end the Virtual Azure Community Day. So thank you, and I hope we see you for the next one.
Cool. Yeah, anytime. I can talk about all these all this stuff. Cool.
Great. Thank you.
Yeah, you're welcome.
Okay. And now I'm gonna try to share my screen, and my my screen just froze, so nothing is working anymore. So I don't know if anyone can hear me because everything is frozen on my side.
Yes. You're still there.
If someone can hear me,
hear you.
I think maybe Philippe can take over.
Okay, you want me to share the slide? Right? Okay. Let's do that.
Hello, I'm back. So my computer just froze completely, and now I'm back. So yeah, it's always, always when you need to go on stage and have an important message to share that these things happen. So yeah, I just switched to Windows 11 yesterday. I don't know if it's because of that, but yeah, it's the first bug I'm having. And so I'm happy that we had this conference, and it's great that you are here, Philippe, because I wanted to put you on the stage also. This wasn't planned to do it like that, but yeah, Philippe has been with us in the backstage for the whole day, so taking care of all the speakers who are coming up and managing the different screens and the sound and everything. So thank you very much. This is great to have you here. And also, I wanted to start by thanking all the different speakers we had. So thank you to Barbara, Maxime, Sergey, Tobias, Alpa, and Ron. It was really great to have you. And also thank you to the different team members. So we have Olivier, who was doing the comments and taking all the questions from the participants on YouTube and on Twitch. Then we have Frederic, Christophe, Tiffany, Adrien, Olivier, Thomas, and Alexa that you have seen on screen before today. So yeah, it was great to have everyone. And also we have some partners who helped organize the event and communicate. So we have the MIC, Microsoft Sense of Tech, the StiMug, which is a community, and the Mug.net, and the Mug Strasbourg. For your information, Mug is Microsoft user group. So these are communities of people who like Microsoft technologies and who like to gather to learn more about these technologies. So thank you. And then I'll switch to the next page. Yeah, it works. Just to present to you the next events, maybe that can be of interest to you. So in October, we have a conference which is hybrid. So it's happening in Los Angeles, but you can also watch it from your computer. So it's a KubeCon and Cloud Native Con. So these conferences are for people who are interested in open source and interested in cloud native technologies. Then you have also at the end of October the GitHub Universe. So it's the yearly conference that GitHub organizes for communities and developers. And then in November, you have Microsoft Ignite, which is the event by Microsoft for developers and IT professionals. So that's for the conference. And before we leave, we don't really want to leave you because we're already thinking about the next Virtual Azure Community Day. So it's going to be the number 5. We don't have a date yet. As you can see, probably it's going to be in a year, so you could probably count on October. In any case, we're already interested in learning about different technologies, different topics you might have in mind. So feel free to already contribute to the call for paper while it's hot. So we just released it today. And yeah, we'd love to have some more of you present for next year. And it was great. Thank you.
Yeah, take your chance to be part of it. We'll be very happy to have you on stage. And by the way, it was a pleasure to run this event with you again and all the team. So thank you very much. And be sure to check out the CFP.
Yeah. Thank you. We'll put the link in the chat.
Yes.
And also for all of the speakers, you can find the recording of your videos on YouTube. We will separate the big video into smaller videos so you can use the videos again for any communication on technologies that you enjoy. Thank you again.
Yeah.
Have a nice day.
Bye.
Bye.